On October 20th, 2025, a private telescope captured something that shouldn't exist. You are looking at the coordinates 13 hours, 48 minutes, 57.33 seconds, negative 8 degrees, 25 minutes, 54.3 seconds. The exact location that NASA provided us for BAE Atlas, but this image, raw and unprocessed, from the solar telescope of an amateur astronomer, shows something that defies all the rules. We know about comets. There is a structure, a heat shield, pointing directly at the sun, a dark nucleus with inverted colors, a conical jet flaring out in the wrong direction. And here's the thing that will stun you. It has no tail. Every comet you've ever heard of has a tail. That's not an option. It's physics. The solar wind pushes gas and dust away from the sun. Always. No exceptions. So what are we really looking at right now? The object currently hiding behind our star. The object arriving at the perfect time for a maneuver. The object emitting industrial alloys that we've only ever seen on human spacecraft. Was just photographed doing the impossible. And today, we're going to look at all the evidence, every theory, every possibility, about what October 29th might bring, when this object reaches perihelion. If you find this as fascinating as I do, please hit like and subscribe. Then, let me know in the comments where you're listening from, and what time it is there. And honestly, tell me if you think this is natural, or something else. And if you want to help our community grow, please share this on X, Facebook, at Reddit, or your Messenger app. Thank you for your continued support. The image that changes everything. The photo appeared on social media at 1600 hours, at 00 minutes, International Time, on October 20th. Username Dobsonian Power, a backyard astronomer with a solar telescope. Nothing fancy. Not affiliated with any institution. Just someone who knew where to point their equipment, and had the technical ability to observe objects near the sun. Time when every major observatory has been strangely silent about doing that exact thing. The image shows BAE Atlas at a distance where it should be exhibiting. Classic cometary behavior. We're talking about an object that has been approaching, as our sun for months now, heating up, and supposedly outgassing, creating the characteristic tail that every comet develops when solar radiation sublimates ice from its surface. That tail should be distinct. It should be prominent. It should point away from the sun like a flag in the wind, because that is how physics and works in our solar system. But that is not what we see. What the image reveals is a forward-pointing jet. It has been described as a heat shield. This jet is aimed directly at the sun, not away from it, but towards it. And before you think that this might be an optical illusion, or an artifact of the imaging process, remember that this is a solar telescope, and specifically designed to observe objects in the vicinity of the sun. The scattered colored dots in the image are hot and cold pixels from the camera sensor. That's quite standard and predictable, but that jet structure, that is a real signal. The nucleus appears dark in the inverted color palette that the observer used. That is normal for this type of solar imaging. What is not normal is the lack of coma activity, and surrounding it that you would expect from a comet at this distance. There is a faint, extended trail, to be sure. The observer notes that it extends toward the top and left of the frame. It's small and subdued, nothing like the giant envelope of gas and dust that should be surrounding an active comet near perihelion. Let's put this in the context of what we know about the physics and comets. When a comet approaches the sun, solar radiation heats its surface, and sublimating water ice, carbon dioxide, and carbon monoxide. These materials do not melt like an ice cube in your drink. They go straight from a solid to a gas, carrying dust particles with them. They escape the comet's weak gravity. This creates the coma, the fuzzy atmosphere around the nucleus, the solar wind and radiation pressure, and push this material away from the sun, creating the tail, and sometimes two tails, a slightly curved dust tail that follows the comet's orbit, and an ion tail that points directly away from the sun, are blown by the solar wind like hair in a storm. This process is so reliable and so well understood that we can predict what a comet will look like at any given distance from the sun, based on its size and composition. We have observed comets for thousands of years. We have sent spacecraft to them. We have landed on them. We understand the behavior of comets in the way we understand boiling water or rusting iron. By Atlas does not follow the script. The user who posted this image made it clear that they would be using a normal telescope in November, after perihelion, to see it directly. Think about that phrasing. After perihelion, after it has looped around the sun. That tells you something about the observation strategy here. A solar telescope is the only way to see objects close to the sun from Earth right now, because of the glare, which would overwhelm any normal telescope. So we depend on specialized equipment, and the few people who have it and know how to use it. This raises an immediate question. Where are the professional observations? Where are the images from the major observatories? We know they have the equipment. We know. By Atlas is a set of coordinates they can calculate down to the finest detail. So why is a backyard astronomer providing us with the evidence? The most recent visual evidence of this object's true form. The timing here is critical. We are at October 21st as you hear this. Yesterday's image shows by Atlas in a configuration that does not match what a comet should be doing. Today, right now, by Atlas is in solar conjunction. It is directly on the opposite side of the sun, relative to Earth, a perfect hiding spot. And in 8 more days, on October 29th, it will reach perihelion, its closest approach to the sun, the moment when a natural comet would be at its most active, the moment when, according to Harvard astrophysicist Avi Loeb, a technological object would perform an upright maneuver to maximize its energy gain from the sun's gravitational field. Let's talk about what we are actually seeing in this image. Structure by structure, a jet is pointing towards the sun. In cometary science, we sometimes see jets. They are localized emissions from specific regions of the nucleus where ice is actively sublimating. These jets can point in various directions, depending on the nucleus's rotation and the location of the active regions, but they are part of a larger pattern of outgassing. They contribute to the overall coma and tail structure. What we are not seeing here is that larger pattern. We are seeing a directional jet, and not much else. Some researchers have suggested that Atlas is exhibiting what they call an anti-tail, a feature that appears to point toward the sun instead of away from it. Anti-tails are a known phenomenon. They are an optical illusion caused by our viewing angle. When Earth passes through or near the comet's orbital plane, the dust tail can appear to point toward the sun because we are seeing it edge on. It's like looking at a frisbee from the side versus from above. The shape seems completely different, but the anti-tail is still part of the tail structure. It is still part of a massive outgassing process. It is still surrounded by a bright coma. The October 20th image doesn't show that. It shows a focused jet, a small trail, emanating from a dark nucleus, and very little else. The dark nucleus itself is also very interesting. In inverted color solar imaging, bright objects appear dark. So, the fact that the nucleus appears dark tells us it is reflecting or emitting light. But the intensity and distribution of that light do not follow the expected pattern. If this were a normal cometary nucleus, we would expect to see it surrounded by a bright coma. In this imaging mode, the coma would appear as an extended halo of light, fading as you move away from the nucleus. Instead, We are seeing defined structures, jets, plumes, and geometric features, rather than diffuse clouds. Now, let's address the obvious objection. This could just be poor image quality. The telescope's resolution might not be sufficient to capture the finer details of the coma and tail. No, think about it. A Dobsonian-style telescope, when properly equipped for solar observation, can resolve significant detail. They are not professional grade, that's true, but they are not toys either. The user clearly captured the nucleus. They captured the structure around the nucleus. If there were a prominent coma and tail, those would be the brightest, most obvious features. They would show up even in a low-resolution image. Think of it like taking a picture of a streetlight on a foggy night. Even with a cheap camera, you would capture the glow. You might not get sharp details, but you would get the glow. We don't see a glow here. Could atmospheric conditions explain that? Turbulence, clouds, humidity, possibly, but it's unlikely. It's unlikely they could completely hide the main structural features, while still allowing a clear image of the nucleus and the jet. Atmospheric effects blur things. They don't selectively hide them. Could the timing of the observation be important? Perhaps Atlas is in a temporary lull. Cometary activity can be variable. Their outgassing can erupt in bursts as different regions of the nucleus and rotate into sunlight, or when subsurface ice is exposed. But we are talking about an object that is only a few days from perihelion. This is when a comet is most active. This is when it is brightest. Most active, most spectacular. A lull right now would be like a kettle falling silent just before it boils. Possible, but strange. Let's step back a bit and consider the wider context. Atlas has been anomalous since its discovery. The list of its unusual features continues to grow with each observation. It began to brighten much earlier than expected. It shows an unusual composition, with an extremely high ratio of carbon dioxide to water. It displays an anti-tail structure pointing towards the sun. Recent spectral analysis shows nickel emissions, without corresponding iron, a signature associated with industrial metal refining. Its orbit brought it into the solar system on an alignment with the ecliptic plane, statistically rare for a random interstellar visitor. Its direction of origin is within only 9 degrees of where the famous WOW signal was detected in 1977. Each individual anomaly can be explained on its own. Statistics produce rare events. Compositions differ among comets, and viewing angles create optical illusions. But when you stack one anomaly on top of another, at some point, you have to consider whether you are forcing a natural explanation and onto something that may not be natural. The October 20th image adds to that stack. It shows an object that should be exhibiting cometary behavior clearly, but isn't, or at least isn't exhibiting it in the expected way. Think about this for a moment. Imagine you are watching water in a pot on the stove. You know the stove is on high. You know the water should be boiling. But when you look, the water is still, perhaps with a gentle ripple. It might be moving in strange patterns, but it's not boiling. Your first instinct might be to question your observation. Maybe the angle is wrong. Maybe the light makes it hard to see the bubbles. But at some point, if the water persists in not boiling, you start to question your assumptions about what's in the pot, or whether the stove is really on at all. You adjust your model of reality to fit what you're observing. Instead of dismissing the observation because it doesn't fit the model, that's where we are with Biela's right now. We expected a comet. We built our predictions, and based on the behavior of comets, and reality keeps delivering something that doesn't quite fit those predictions. A user posting an image said, "They will observe again in November with a normal telescope, after perihelion. That is when Bay Atlas will reappear from behind the sun and be visible from Earth once more. That is when we will have another chance. And to see what it looks like, what condition it's in, whether it survived perihelion intact or broke apart like a fragile cometary nucleus, is supposed to do when subjected to the sun's tidal forces and intense heat. But November is still a little while away. Right now, today, Borealis is on the far side of the sun, hidden from our view at solar conjunction, and tomorrow, and the day after, and the day after that, be moving toward perihelion, toward that moment on October 29th, when it receives maximum solar flux, when, if it is technology, it could perform its most energy-efficient maneuver, when, if it is natural, it will put on its brightest display of outgassing and tail development that we have ever seen from it. We will not see that moment directly. Telescopes on Earth cannot observe through the sun, but we will see the aftermath. We will see what emerges from behind the sun. Early November. We will see if this object disintegrates, as Avi predicts a natural comet would, or if it remains intact and capable of deploying something, as he suggested a technological object could. The October 20th image is crucial, because this is the clearest look we finally have before that hidden window closes. This is the baseline, the before photograph, and what it shows is an object that was not behaving as expected, an object with a forward-facing plume and a minimal coma. There was no distinct tail, and a structure that looked more defined, more geometric, more intentional than the chaotic outgassing of a sphere of natural ice being heated by a star. One more detail is worth noting. The observer specifically mentioned this is a 100% raw, unprocessed photograph. In astrophotography, processing is common. You stack images to reduce noise. You adjust the curves to bring out faint details. You subtract the background. But raw images are valuable because they show what the sensor actually captured, without any enhancement or interpretation. Unprocessed means no artifacts were introduced by software. There are no algorithmic decisions about which details to emphasize. It's just the photons hitting the detector and being recorded. That raw, unprocessed nature makes the absence of a prominent tail all the more significant. If there were a tail, even a faint one, it would have appeared in the raw data. Bright tails. They scatter sunlight efficiently. They are designed by physics to be visible. A raw image would capture them easily if they existed. As for the conical plume to the upper left, that the observer noted, that is also very interesting. It's small, localized, not the spherical expansion you would expect from isotropic outgassing. It's more like a directed release, like something being pushed out in a specific direction for a specific reason. We have reached a point where the question is not whether Atlas is strange. It clearly is. The question is whether that strangeness falls within the vast range of natural possibilities for an interstellar comet, or whether we are looking at something that our current models do not explain. And that is what makes the next 8 days so critical. Whatever Atlas truly is, it is about to endure the most extreme conditions. It has faced since entering our solar system. The sun's gravity will pull on it with maximum force. Solar radiation will bombard it with maximum intensity. If it is a fragile collection of ice and dust, held together by weak forces, it would break apart unless it were something more robust, something designed to withstand these conditions. It would not. We will soon know. The countdown is running. October 29th, 8 days away. And right now, hidden behind our sun, Atlas is moving toward that day, carrying with it all the questions we haven't answered, and all the anomalies we haven't explained. And now, thanks to an amateur astronomer with a solar telescope, another piece of evidence has emerged, showing that this object does not follow the rules. The evidence suggests this is not a comet. A second image came from a completely different observer. The user Busygate posted deep space footage. Emitted light, whether from chemical reactions or thermal processes, or something else, appears smooth and controlled. It doesn't have those surface fingerprints. The video shows this object against a starfield background. The stars appear as expected, sharp, distinct point sources of light. But Atlas doesn't appear as a point source, or even an extended, nebulous cloud as a comet. It often does. It appears as a shape, a form, something with a clear structure and size. Many who view this footage describe it with the same word, mothership. Now, that is obviously a loaded term. It implies an artificial origin. It implies purpose and design. But it also captures something about the visual impression that is hard to shake. This looks like something that could contain other things, something with internal space. Something constructed rather than accreted. Let's systematically consider the natural explanations. Could this be a cometary nucleus, with symmetrical outgassing creating an elongated appearance? Theoretically, yes. If you have an elongated nucleus with active jets firing from both ends along the long axis, you could create this kind of linear visual signature. The jets would extend the apparent length, and the nucleus would be the bright central region. The gas would fan out as it disperses. But cometary jets are rarely symmetrical. They come from active regions where subsurface ice is exposed to sunlight. Those regions are distributed essentially at random, based on the object's history of formation and impacts. For jets to align perfectly along the long axis in opposite directions requires very specific conditions. It's not impossible, just unlikely. And even if you had that configuration, we would still expect to see some asymmetry, some irregularity, or some sign of the physical processes, the chaos that drives the outgassing. This footage shows none of that chaos. It shows order. Could perspective be a factor? Absolutely. When you observe any three-dimensional object, your perception of its shape depends entirely on your point of view. A disk viewed edge-on looks like a line. A sphere viewed from any angle looks like a circle. So perhaps Bay Atlas is actually a more conventional shape, and we are simply seeing it from an angle that makes it appear elongated and structured. But here's the problem with that explanation: we have multiple observations from many angles for months now. Bay Atlas has moved through space. The Earth has moved in its orbit. The viewing angle has changed continuously. If this were an error of perspective, we would expect its appearance to change dramatically. As those angles change, we would see the object appear to rotate, to change its shape, or reveal different features. Instead, what multiple observers are reporting is this consistent, elongated, structured appearance. Could this be an imaging artifact? Could the telescope, or the camera, or the processing be creating features that are not really there? In astrophotography, artifacts are common diffraction spikes from telescope support struts, blooming from oversaturated pixels, cosmic rays striking the sensor, atmospheric distortion. You always have to consider whether what you are seeing is a true signal or an instrumental artifact. But artifacts have characteristic signatures. Diffraction spikes are symmetrical and centered on bright point sources. Blooming spreads along pixel columns. Cosmic rays appear as sharp lines or dots. Atmospheric distortion causes blurring, but it does not create structured shapes. None of that fits with what we are seeing. The shape in this footage is too consistent, too stable, too geometric. Another factor weighing against the explanation of an error is that many independent observers are now reporting similar visual features to the Dobsonian Power Solar Telescope images. This deep space footage from October 20th. Different equipment, different observers, different imaging techniques. However, both show an object that doesn't match the appearance of a standard comet when independent observations converge on the same unusual feature. You have to take that seriously. Let's talk about what we don't see in this footage, because the absence of evidence can be as telling as its presence. We don't see a prominent coma. A comet at this distance from the sun should be surrounded by a massive envelope of gas and dust. That coma should be its most obvious feature, should dominate the view. But in this footage, if a coma is present, it is minimal, barely visible. It is certainly not the massive structure we would expect. We don't see a tail, not a dust tail, nor an ion tail. Nothing is streaming away from the sun. The object appears to be completely self-contained, not shedding material in the dramatic way an active comet should. We don't see the kind of fuzzy, irregular outline characteristic of cometary bodies. The edges seem defined. The shape appears coherent. There is a sharpness to it that natural objects in space rarely exhibit. Now, let's address the elephant in the room. Why does this look manufactured? Human perception of artificial forms versus natural ones is deeply ingrained. We are pattern recognition machines. Evolution has shaped our brains to distinguish between things that grow and things that are made. Natural objects have certain characteristics: asymmetry, irregularity, fractal complexity. Artificial objects have different characteristics: symmetry, regularity, geometric simplicity. These are not absolute rules, but they are strong statistical tendencies. When you look at this footage of Atlas, your brain is processing those visual cues and returning a classification of artificial. And while our intuition can be wrong, it is also the product of millions of years of selective pressure favoring accurate pattern recognition. We shouldn't completely dismiss that reaction. The brightness profile adds to that manufactured impression. The light seems uniform along the length of the object. It doesn't flicker, or vibrate, or show the kind of changes you would expect from a block of ice. One that is irregularly shaped, tumbling as it reflects sunlight. It is stable and consistent, as if it comes from a surface with uniform properties, or as if it is being actively generated. Let's consider for a moment what a spacecraft designed for interstellar travel might actually look like. not the sleek torpedoes of science fiction, or the practical engineering of crossing light years. You would want to minimize surface area. To reduce drag from the interstellar medium, you would want a long, thin profile. To reduce exposure to cosmic radiation for any systems on board, you would want structural rigidity along a single axis to handle the forces of acceleration. You would want thermal systems that can radiate heat efficiently, a form with an elongated structure and uniform surface properties. All in all, that is not a bad design for an interstellar probe. It's actually quite logical from an engineering standpoint. Now, does that mean this object is definitely artificial? No. It means the visual evidence is consistent with that possibility. It means we cannot rule it out based on its appearance alone. The video also gives us some sense of how this object moves through space. It doesn't tumble chaotically like a typical asteroid or comet nucleus. Those objects usually rotate on multiple axes, wobbling and spinning as they travel. This object seems to maintain a consistent orientation, its long axis remaining aligned with its direction of travel, based on the limited motion visible in the footage. That stable orientation is another small anomaly to add to the growing list. Natural objects tumble. They don't maintain a fixed attitude unless some force is acting to stabilize them. For Earth satellites, it might be intentional rotation, or reaction waves, or magnetic torpors. For a natural comet in deep space, there are no mechanisms for attitude control. They just tumble. They tumble in whatever manner their history of formation and collisions has left them. So why isn't this object tumbling noticeably? Maybe it is. We just don't see it because the observation window was too short. Maybe it has a very slow rotation speed, which wouldn't be obvious until we had a longer observation time. Perhaps its elongated shape means it looks similar from many angles, concealing its rotation. It's all possible. Or perhaps it is intentionally maintaining its attitude. The footage does not answer that question definitively, but it poses the question in a way that is hard to ignore. One more element is noteworthy. The object appears to be self-luminous in this deep space view. It is bright against the dark background. Comets can appear bright. They reflect sunlight effectively when they have an active coma. But this brightness has a different quality. It is not the scattered light of dust particles catching the sunlight. It is more direct, more intense, as if the object itself is a source of light. Could this be thermal emission at Comet Atlas's distance from the sun? It is currently receiving significant solar flux. That energy has to go somewhere. Some is reflected, some is absorbed and radiated away as infrared. If the object has a low albedo, absorbing most of the incoming light, it would heat up and glow at infrared, red, and even visible wavelengths. But the brightness we are seeing doesn't quite fit that explanation. Thermal emission from solar heating should be strongest, on the side facing the sun and dimmer on the dark side. We would expect to see a variation in brightness across the object's surface. Instead, the light appears remarkably uniform. The caption accompanying this video calls Comet Atlas a comet, and then immediately contradicts that classification. It looks nothing like a comet. That contradiction captures the fundamental tension here. We have an object that is supposed to be a comet, based on its orbit and origin, but its appearance consistently contradicts that classification. How many contradictions can we stack up? Before we reconsider the initial assumption, the solar telescope images show no tail and forward-directed jet. This deep space footage shows an elongated, structured form with uniform brightness and no coma. Spectral analysis reveals signatures of industrial metals. The orbit is aligned with the ecliptic plane in a statistically improbable way. Timing brings it to a solar conjunction just before perihelion. The size makes it over 1 million times larger than the interstellar visitor. How previously, each individual anomaly could be explained or rationalized, but taken together, we paint a picture of an object that doesn't fit our models, an object that continually surprises us, an object that looks more and more like something for which we have no natural category. That is terrifying and fascinating in equal measure, because if B.I. Atlas is not a comet, if it is something else, then everything about the next 8 days changes. The questions change. The stakes change. What we are looking at changes. A natural comet at perihelion puts on a show. It brightens considerably, sheds material, and might break apart due to tidal stress. That's spectacle. That's beautiful. That's safe. Something else at perihelion. That's unknown. That's unpredictable. That's when we find out whether the 40% odds of artificial origin are too high or too low. October 13th, Fibonacci transmission. October 13th, 2025, the 108th anniversary of the miracle of the sun at Fatima, Portugal. On that day, in 1917, an estimated 70,000 witnesses reported seeing unexplained solar phenomena during an event. During a Marian apparition, the sun was alleged to have danced in the sky, changing colors, and seemingly plummeting towards the Earth. Mass hysteria, atmospheric optics, religious experience. Historians and skeptics have debated it for over a century. On October 13th, 2025, exactly 108 years later, researcher David Sita reported observing structured light pulses from B.I. Atlas, not random fluctuations, not equipment noise, a Fibonacci sequence pattern, 5 pulses, 8 pulses, 13 pulses, repeating 1, 1, 2, 3, 5, 8, 13, 21, 34. Each number is the sum of the 2 preceding it. The Fibonacci sequence appears in nature, in spiral galaxies, nautilus shells, flower petals, pine cones, the DNA helix. It is the mathematical signature of growth, of optimal arrangement, of natural efficiency. To find it in the light patterns from an interstellar object coming to our sun would be extraordinary. To find it on the anniversary of Fatima would be, well, choose your own word. Coincidence, synchronicity, message, warning. Consider what Zeta actually claimed to have observed, and what it would mean if verified. The light pulses were said to follow the 5, 8, 13 pattern. 3 consecutive Fibonacci numbers, not 1. 1, 2, not 8, 13. 21, but specifically 5, 8, 13. In Serrata's cosmological framework, and this is where things become speculative. These numbers correspond to planets in a model of an expanded solar system. 5 represents Earth. 8 represents a hidden planet he calls Dominion, or Planet 591, and 13 points to another unseen world named Virgo, or Methuselah. Now, mainstream astronomy does not recognize these additional planets. Our solar system has 8 confirmed planets, after Pluto was reclassified. There is ongoing discussion about a possible major planet in the distant outer solar system, based on the orbital perturbations of trans-Neptunian objects. But C.J.'s model proposed many additional celestial bodies, some of them hyperdimensional, based on esoteric and alternative physics frameworks. Whether you accept that cosmology or not, the observational claim itself is worth considering. Light pulses in a mathematical sequence from an object that should not be producing structured signals at all. Sarita connected this to the work of researcher Richard C. Hoagland, who apparently decoded the significance of the number 108. 108 is a frequency octave of 432. That number, 432 hertz, holds significance in certain esoteric traditions as a sacred or harmonic frequency. The math works out 108 times 4 equals 432. whether that mathematical relationship has any meaning in physical reality is another question. The theory extends further. Reported receiving a vision instructing him to add 432 days to October 19, 2024. That calculation lands on Christmas Day, 2025, December 25th. On that date, according to this model, Atlas will be at its closest point to Earth and positioned at the same angle as the Great Pyramid of Giza, relative to some celestial reference frame. This prediction is testable. We can calculate where Atlas will be on December 25th, 2025. We can check its position relative to Earth. We can measure the angles. So we will know in 2 months' time whether this specific prediction holds any validity. But let's return to the central claim. The Fibonacci pulses on October 13th. For this to be a real signal, rather than pattern recognition and noise, several things would need to be true. First, multiple independent observers would need to detect the same pulse pattern. One person seeing patterns could be pareidolia. The human brain is exceptionally good at finding patterns. Even in random data, we see faces in clouds. We hear words in white noise. We find meaning in coincidence. That's not a bug. It's a feature, but it means. Reports from a single observer need a second corroboration. The pulses would need to appear in instrument data, not just a visual observation, light curves from photometry, and spectral variations, something objective that multiple instruments can record and analyze. Eyewitness testimony is valuable for initial detection, not enough for confirmation. Third, the pattern would need to repeat or show some consistency across multiple observation windows. A single series of 83 pulses could be random. If the pattern repeats multiple times over hours or days, that would be far more significant. To date, we don't have that publicly available corroboration. Series report has stood alone. That doesn't make it wrong. It makes it unconfirmed. There's a difference. Science demands reproducibility. Extraordinary claims require extraordinary evidence. A single report of mathematical pulses from an interstellar object is interesting, but not conclusive. Now, this is where the story takes a darker turn. According to claims circulating in the same circles, NASA's Solar Dynamics Observatory went offline on October 13. SDO is a spacecraft that continuously monitors the sun. It provides real-time images and data on the sun's activity. If you wanted to observe something near the sun, SDO would be one of your primary tools. The claim is that SDO's public data feeds went dark on the same day reported observing the Fibonacci pulses. Coincidence, a technical glitch, a deliberate act to prevent verification. Let's examine that claim. NASA usually announces when major spacecraft have technical issues. They maintain status pages, and the scientific community would notice. And the primary solar observatory went offline. So, either this happened and was publicly acknowledged, and or it didn't happen and this is misinformation, or it happened in a way that wasn't widely reported. Similar claims mention that the high-rise imaging systems of been unavailable since October 10th. HiRISE, the high-resolution imaging science experiment on the Mars Reconnaissance Orbiter, is capable of capturing detailed images as BA Atlas passes near Mars in early October. HiRISE would be in a perfect position to observe it up close. Images from that flyby would show surface details, composition, and precise structure, which is exactly the data we need to determine what this object truly is. If HiRISE has been offline since October 10th, that is a matter of timing. It raises the question of whether it was offline before or after it had the opportunity to photograph BA Atlas. If before, was it planned maintenance or an unexpected failure? If after, where are the images? These are verifiable claims. NASA publishes spacecraft status and mission activity reports. If HiRISE was inactive for 3 weeks, there must be documentation. If not, then this claim is false, and we can dismiss it. But here's the uncomfortable part. Even if these claims about this observatory shutdown are false, even if they are conspiracy theories with no basis in fact, they are spreading. People are believing them, and that belief is shaping how people interpret everything else about BA Atlas. When you think there is a cover-up, every piece of missing information looks like proof of that cover-up. Every unexplained detail becomes evidence that someone does not want you to know the truth. This is how conspiratorial thinking reinforces itself. The absence of evidence becomes evidence of absence. The cover-up hides the evidence, which proves there is a cover-up. It is circular. It cannot be refuted. And it is incredibly powerful in shaping perception. Therefore, we must be careful. We must separate what we can verify from what we cannot. We must acknowledge when we are speculating versus when we are reporting confirmed data. What can we verify? David Sereda made the claim about observing Fibonacci pulses on October 13th. That claim exists. We can verify that he said it. Whether the observation itself is real, however, is unconfirmed. October 13th is the 108th anniversary of the Fatima event. That is a verifiable historical fact. Whether that anniversary has any significance for the interpretation of BA Atlas is not a fact. The Fibonacci sequence appears in nature. That is a mathematical and biological fact. Whether its appearance in the alleged light pulses from an object has any significance or not is unclear. Atlas was positioned between the Earth and the Sun around October 13th. That's orbital mechanics. We can calculate the positions. Whether it emitted structured signals or not is unconfirmed. Now, let's talk about what it would mean if the Fibonacci pulse claim were true. Not proven, just hypothetically true. What would structured mathematical signals from Atlas tell us? First, it would tell us the object is not natural. Natural processes do not produce Fibonacci sequences and light pulses. They do produce Fibonacci sequences and physical structures through growth and packing algorithms, but not in signal patterns over time. A repeating mathematical sequence in the light output would be initial evidence of an artificial origin. Not proof, very strong evidence. Second, it would tell us the object is actively signaling, not just reflecting light, not just radiating heat, actively modulating its output in a pattern that requires energy, purposeful control. Those are attributes of technology, not geology. Third, the specific choice of Fibonacci would tell us something about the intent. Why use that sequence if you are signaling? You could use any pattern. Prime numbers would work. Powers of 2 would work. Morse code would work. But Fibonacci is special because it's universal. Any technological civilization that understands mathematics would recognize it as a nature-based pattern. So, it bridges the gap between the natural and the artificial. It says, we know math, we know nature, we understand the relationship between them. Fourth, the timing on the Fatima anniversary would add a layer of complexity. Was it targeted? Is the object aware of human religious and historical events? That would imply reconnaissance, intelligence gathering, long-term observation of Earth. Or is it pure coincidence? And we are assigning meaning to a random alignment. Fifth, if the numbers 5, 8, and 3 correspond to planetary positions, as C, D, Da suggested, that would indicate that the object is conveying information about the architecture of the solar system, telling us something about planets we have not yet discovered, or are not perceiving correctly. Why would an interstellar traveler be interested in teaching us about our own solar system? Unless there is something about that architecture we need to know. Let's consider the prediction for October 25th, 2022. If by Atlas truly ends up at its closest approach to Earth on Christmas Day, at a specific angular position, aligned with the Great Pyramid, what would that mean? It could mean the entire trajectory was planned, that this is not a random interstellar object just passing through, that it was sent here deliberately, that whoever or whatever sent it knew enough about Earth to time its visit to coincide with symbolic dates and geometric alignments. Or it could mean that we are searching for patterns in coincidence. Earth's orbit is predictable. Any object on a given trajectory will cross Earth's orbital path at calculable times. If you search hard enough for alignments with human structures and dates, you will find them. There are thousands of ancient monuments, 365 days in a year, and countless geometric angles. Some alignment is almost guaranteed by statistics alone. The question is whether that alignment is tight enough, specific enough, and improbable enough to demand an explanation. Beyond mere chance, we will not know until October 25th, 2022. That is the beauty and the frustration of testable predictions. They give us a deadline, a moment when the hypothesis either holds or collapses. In 2 months, we will know if this particular thread of inquiry leads anywhere, or if it was simply noise all along. But this is what troubles me about the claims for October 13th. If they are false, if there is no Fibonacci pulse, if the observatory shutdown does not happen, then we have wasted time and attention on a fantasy. We have mistaken signal for noise at a critical time when we need clarity. If they are true, if some aspect of this is real, then we are dealing with something far stranger than a random interstellar. We are dealing with something that is communicating, something that times its actions according to human events, something that wants us to pay attention. Both possibilities are uncomfortable. The first possibility means we are getting lost in conspiracy thinking when we should be doing science. The second possibility means that we might actually be receiving a communication, a contact from something that has traveled many light years to be here. The orbit takes Atlas between Earth and the Sun multiple times over the next few months. October 19th to October 30th is the current window, with perihelion on the 29th. That's when it is hidden behind the Sun from Earth's perspective, but it will emerge again. We will have more opportunities for observation. If there are pulses, if there are patterns, we will have the chance to detect them with the right equipment. That is what needs to happen next. Rigorous observation, multiple instruments, multiple observers, data sharing, peer review, the process that science uses to separate signal from noise. Without that process, we are just collecting anecdotes, and anecdotes, no matter how compelling, do not constitute evidence, so we are left with uncertainty. The claims cannot be immediately verified or refuted. The patterns could be real, or they could be pareidolia. The timing could be significant, or it could be a coincidence, and an object currently hidden behind the Sun could be about to do something extraordinary, or it could be about to break apart like any ordinary comet. The Fibonacci transmission story is exactly the kind of thing that makes Atlas so difficult to analyze. It is just plausible enough that you cannot dismiss it entirely. It is just unconfirmed enough that you cannot accept it uncritically. It resides in that uncomfortable space between the known and the unknown, between evidence and interpretation, between science and speculation. And while we sit in that uncertainty, the clock continues to tick. October 29th is approaching. Whatever Atlas is, whatever it is doing, we are about to find out. The Fibonacci pulses, real, could be the first structured communication, or they could be the first in a long list of misconceptions about this object. History will judge which it is. But history requires data. And right now, data is the one thing we need more of. Its position today. A perfect hiding place, right now, as you are hearing this. BAI Atlas is on the opposite side of the Sun from Earth, in solar conjunction. Imagine drawing a straight line from Earth through the Sun and continuing it out to the other side. BAI Atlas is somewhere along that line, hidden and unobservable, behind 149 million kilometers of glowing hot plasma. This is not an accident of timing. This is orbital mechanics playing out exactly as physics demands. But its precision, its consequences, are worth considering. Solar conjunction means that BAI Atlas is in a unique place in the inner solar system, where it cannot be observed by telescopes on Earth. The sun's glare overwhelms everything near it in our sky. Even if you had the most powerful telescope on Earth, pointing it anywhere near the sun means looking through the sun's corona, the sun's chromosphere, layer after layer of intense light and heat, drowning out any signal from behind. Space telescopes also face a similar limitation. Point Hubble at the sun, and you fry its instruments. Point Webb at the sun, and you risk damaging the telescope itself. Solar observing spacecraft, like SDO or SOHO, are designed for the sun, not for faint objects passing behind it. They might catch a glimpse if BAI Atlas transits the solar disk, but even that is unlikely, due to the object's relatively small size and the overwhelming brightness of the photosphere. So, during this window, this critical window just before perihelion, we are blind. Atlas could be doing anything right now, and we would not know. It could be breaking apart, outgassing violently, changing its trajectory, deploying objects. We would not see it, not until it emerges from behind the sun in November. That is just physics. It is just the geometry of orbits and the limitations of observation. There is nothing necessarily sinister about it, except for one detail. While BAI Atlas reached solar conjunction on October 21st, it reaches perihelion, its closest approach to the sun, on October 29th. 8 days between conjunction and perihelion. 8 days when it is perfectly positioned to perform what is known as an Oberth maneuver, all while hidden from our view. Let's talk about Oberth maneuvers, because they are central to this. To understand why this moment is so important in space travel, when you want to change a spacecraft's energy in the most efficient way, you fire your engines at the point of highest velocity. This is counterintuitive. You might think it would be more efficient to fire the engines when you're moving slowly, but the math works out differently. Kinetic energy is proportional to the square of velocity. So, adding a certain amount of speed when you are already moving fast gives you a much greater gain in kinetic energy than adding that same amount of speed when you are moving slowly. This is the Oberth effect, named after Hermann Oberth, one of the founding figures, rocketry, and space travel. And it's not just a theory. Every interplanetary mission uses Oberth maneuvers. When we send probes to the outer solar system, we have them dive near the sun or a planet, then fire their engines at the closest point of approach. Maximum velocity means maximum energy gain. For by Atlas, perihelion is that moment, October 29th, when it is closest to the sun, when the sun's gravity has accelerated it to its peak velocity. That's when any applied thrust, whether from a rocket engine or something more exotic, will produce the maximum change in energy. If you were designing an interstellar mission and needed to change course or deploy sub-probes after arriving in the solar system, you would plan that maneuver to happen at perihelion. It's not optional, it's optimal. It's what any aerospace engineer who is competent would do. So, the fact that Atlas reaches perihelion while hidden from Earth's observation is, from a mission planning perspective, perfect. You get maximum maneuver efficiency within a time window when the target civilization can't see what you're doing. Avi Loeb has pointed this out in his recent analysis. This period of concealment was it planned as a window of opportunity for some technological action? That is the question, and it is not a frivolous one. It's the kind of thing you would want to know before October 29th arrives. Let's calculate what is actually happening with Atlas right now in terms of energy and its environment. The solar flux at 1.44 astronomical units, which is roughly where Atlas will be at perihelion, is about 950 watts per square meter. That is the amount of solar energy that hits each square meter of its surface, for an object with a diameter of 5 kilometers, assuming a spherical geometry for simplicity. The cross-sectional area is about 19.6 million square meters. Multiply that number by the solar flux, and you get 18.6 gigawatts of energy hitting the surface. 18.6 gigawatts. That's more than 10 nuclear power plants. That's a huge amount of energy. Most of it is reflected if the surface is bright. Some is absorbed and re-radiated as heat. But if you could capture and use even a fraction of that power, you would have a huge resource available. What could you do with 18 gigawatts for a few hours around perihelion? If you're a comet, you sublimate ice, you create gas, you build up pressure until it erupts through surface fissures. In the form of jets, you lose mass, but are propelled by your own outgassing. You might break apart from thermal stress. If you are a technological object, you charge your batteries, you power up your systems that have been dormant during the long journey through interstellar space. You run diagnostics, you transmit data, you deploy subcomponents. The sun's push provides energy, its gravity provides velocity. Together, they provide you with the tools to do whatever your mission requires, and you do it while hidden from the prying eyes of the civilization, the one you are visiting. Is that what is happening? We don't know. We can't know. We are on the wrong side of the sun, but the possibility is there, like a weight in your chest. The idea that right now, today, something could be activating after a journey of billions of years, and we are too far away and blocked from seeing it. Consider the alternative, that Atlas is exactly what mainstream astronomy says it is, a natural comet of ice and rock from another star system, ejected during planetary formation, drifting through the galaxy for eons, happening to pass through our solar system now. If that's true, then the solar conjunction is just bad timing for observation. Unfortunate, but meaningless. The comet doesn't know we are watching. It doesn't care. It is following the laws of gravity and thermodynamics without any awareness or intent. The perihelion occurring when it did. The fact that it happened while unobservable from Earth is a pure coincidence, perhaps an impossible one, but coincidences happen. Flip a coin 10 times and get 10 heads. It's improbable, but someone, somewhere, might experience it. The natural explanation only requires one thing, that BAE-Alas is a comet, that all the anomalies we've observed have conventional explanations, that we just haven't found yet, that the nickel without iron is some rare chemical process we don't understand, that the apparent lack of a tail is due to viewing angle or timing, that the elongated structure is just the way this particular object happened to be shaped, that the orbital alignment with the ecliptic plane is a statistical chance, that the connection to the direction of the wow signal is a coincidence, that the Fibonacci numbers are pareidolia or a hoax, that the timing of the solar conjunction before perihelion is just luck, one improbability, sure. 2. Okay, 3 gets uncomfortable, but 7, 8, 9 improbabilities at some point. The compound improbability exceeds the improbability of the alternative hypothesis. At some point, the artificial origin becomes the simpler explanation. This is where Loeb concluded a 30 to 40% chance of an artificial origin. Not a certainty, not even a majority probability, but significant enough to warrant serious consideration and preparation. Preparation for what? Though, what do you do? If you suspect an interstellar object might be technological, it might be doing something at perihelion, you observe, using every asset you have, every telescope that can see that region of space, every spacecraft with the instruments pointed in the right direction. You gather data. You look for changes in trajectory that cannot be explained by gravity, gassing. You look for emissions that indicate power generation or propulsion. You look for deployments. And this is where the claims about the observatory shutdowns become relevant again. NASA's solar monitoring systems went offline around October 13th. If the Mars orbiters lost imaging capability just when they could have imaged BAY Atlas during its Mars flyby, if there are gaps, is unexplained in the observations during this critical period. Then we must ask why. Accident, conspiracy, or something else. The simplest explanation is often the right one. Spacecraft malfunction, equipment failure, scheduled maintenance. These things happen. Space is very harsh. Equipment breaks down. The timing is suspicious. For a critical imaging system to fail, October 2025 would be the worst possible time for it to happen. The only time in recent history when we are trying to characterize an object that could be the most important discovery in human history. Though, either we are experiencing a terrible string of bad luck with the timing of the equipment, or there is some coordinated factor that we do not see. Both explanations are unsettling. Let's talk about what we expect to see. If by Atlas survives perihelion intact, and if it is a comet, we would expect to see it brightened by a lot. Comets often brighten by several magnitudes. As they get closer to perihelion, the heating from the sun increases, driving more outgassing. More gas means more scattering of light, and more dust is released. The object would become significantly more visible, not less. We would see the development of a tail. Both the dust tail and the ion tail would grow significantly by early November. When Bi Atlas emerges from behind the sun, it should have prominent tails pointing away from the sun. If we do not see those tails, that would be significant. We might also see fragmentation, tidal stress from the sun's gravity, plus thermal stress from solar heating can tear a comet's nucleus apart. We have observed this many times. Comet Shoemaker-Levy 9 broke into more than 20 pieces before impacting Jupiter. Comet Ison disintegrated at perihelion in 2013. If by Atlas is a loosely bound collection of ice and rock, it might not survive perihelion as a single object. On the other hand, if it is technological, we might not see any of that. We might see an object emerge from perihelion essentially unchanged, the same structure, the same appearance, perhaps slightly brighter due to thermal heating, but fundamentally intact. There might be changes to its trajectory, suggesting that thrust was applied. There could also be new objects accompanying it that wasn't there before perihelion. That's the test. That's how we'll know. Not from speculation, not from blurry images and vague signals, from what happens on October 29th and what we observe in November, when the object becomes visible again. In 8 more days, we will have answers, or at least, we will have new data that brings us closer to the answer. 8 days might not seem like much, but when you're waiting to find out whether humanity is alone in the universe, or whether we are being visited by technology from another star, 8 days feels like an eternity. The object is out there right now, on the other side of the sun, in the perfect hiding spot, at the perfect time for a maneuver. is receiving gigawatts of solar energy, experiencing peak velocity, and we can't see it, can't monitor it, can't know what it's doing. We are blind, and by Atlas, M is exactly where it needs to be to do whatever it came here to do. If it came here to do anything at all, that ambiguity is maddening. That uncertainty is the space we're living in right now. Not knowing, unable to know, just waiting for October 29th to pass, and for November to arrive, and for the object to emerge from behind our star and show us what it has become, the von Neumann AI nightmare from the stars. Let's talk about what could really be inside by Atlas. If it is artificial, not little green men, not biological entities of any kind, but something else, something that makes much more sense for crossing interstellar distances. Machines. This idea originates with John von Neumann, the brilliant mathematician and physicist, who essentially invented game theory, the formalism of quantum mechanics, and computer architecture, and self-replicating systems back to the 1940s and 50s. Von Neumann explored the theoretical possibility of machines that could reproduce themselves, not just performing tasks, but actually building copies of themselves by using raw materials and energy from their environment. A von Neumann probe, in the context of space exploration, is a spacecraft that could travel to another star system using local resources to build copies of itself and send those copies to additional star systems. One probe becomes two, two become four, four become eight, growing exponentially with enough time. A single self-replicating probe could explore every star system in the galaxy. The math is very simple. The galaxy contains about 200 billion stars. If a probe takes 1,000 years to travel between systems and 100 years to replicate once it arrives, you could explore the entire galaxy in a few million years. That sounds like a long time, but the galaxy is 13 billion years old. Intelligent life has had millennia to develop and deploy such systems. So, where are they? That is the Fermi paradox. If self-replicating probes are possible and efficient, why haven't we detected any? Either they don't exist, or we don't recognize them when they appear, or they are deliberately hiding. The ALAS object could be our first identification. This is why machines make sense for interstellar travel. Biology is fragile. Living organisms need stable temperatures, a breathable atmosphere, water, food, and protection from radiation. They age, they die, they require massive life support infrastructure. Sending biological entities across light years is technically possible, but extremely inefficient. You are transporting tons of life support equipment to keep a few kilograms of organic tissue alive. Machines do not have those limitations. A machine can operate in the harsh vacuum, in extreme cold, in intense radiation. A machine does not age the way organisms do. Components may degrade, but properly designed systems can last for millions or billions of years. A machine can enter a state of hibernation, a low-power state during the long journey between stars, only waking up as it approaches its destination. Most importantly, a machine can be patient. Interstellar travel, at any achievable velocity, takes thousands or millions of years. Biological crews would need generation shifts to closed-loop ecosystems, with multiple generations living and dying throughout the journey. Machines simply wait for time to pass. Systems operating at a minimal power load do not get bored, have no existential crises, and just execute their programming. The probe approaches the target star. Solar panels deploy. Power systems activate. Sensors begin to scan. Communication arrays extend. The mission begins after a journey spanning geological timescales. The probe awakens and begins its work. This is what an AI atlas could do. Not a ship full of aliens, but a precision automated platform. Artificial intelligence, literally, a thinking machine, sent to collect data about our solar system and report back to whoever or whatever built it. Or something more unsettling, a berserker probe. The berserker hypothesis is named after the war machines, the self-replicating ones in the science fiction novels of Fred Saberhagen. It proposes that intelligent civilizations might build probes designed to find and eliminate other technological civilizations before they become a threat. It is the ultimate expression of the dark forest theory. Do not communicate. Do not make contact. Just eliminate any potential competitor before they develop to the point where they can threaten you. Why would a civilization do this competition for resources? Assessing existential threats. The logic of preemptive strikes. If you assume that all civilizations will eventually compete for the same finite resources, and if you assume, and you cannot predict which civilizations will be hostile, then the safest strategy is to eliminate them all. It is game theory applied to galactic scale conflict. Horrifying, but mathematically rational. A berserker probe, and would search for technosignatures, radio emissions, industrial chemicals in an atmosphere, signs of spaceflight. When it detects a civilization that has reached a certain threshold of development, it attacks, perhaps with kinetic energy, accelerating to a high velocity and impacting the whole planet, releasing energy equivalent to millions of nuclear weapons, or perhaps with engineered pathogens, and if the target is biological, or perhaps with information weapons, corrupting the civilization's computer systems and infrastructure. The probe does not need to be large, an object weighing 1 ton, moving at 10% of the speed of light, and carries kinetic energy equivalent to 500,000 megatons of TNT, more than 10 times the combined yield of all nuclear weapons on Earth. On Earth, a civilization-ending impact, the probe continues to its next target. Is Bi-Atlas a berserker? Almost certainly not. We are still here. It passed near Mars and didn't attack. It had opportunities to attack Earth and did not take them. Unless the attack is still coming. Unless October 29th is the activation date. Unless the appearance of a comet is a disguise. And we are about to find out. So, why is stealth important in interstellar war? Let us consider a less apocalyptic scenario. The Bi-Atlas is a probe sent by a civilization, curious, cautious. The probe arrives, it observes, it collects data, it determines the threat level. Then, it either makes contact, continues to observe, or leaves. No violence, just information gathering. What would such a probe look for electromagnetic emissions? We have been broadcasting radio and television signals for a century. This bubble of human-made radio noise has been expanding for 100 years, in every direction at the speed of light. Any civilization within that radius, with sufficiently sensitive receivers, would know that intelligent life exists in this solar system. Chemical signatures in Earth's atmosphere. Oxygen, at the levels present in Earth's atmosphere, is unstable. It shouldn't exist unless something is constantly replenishing it, and that something is photosynthetic life. Chlorophyll has a distinctive spectral signature. An advanced civilization observing our solar system from light years away could detect the presence of life on Earth simply by analyzing the light that passes through our atmosphere. Then there are artificial structures, cities that glow at night. You can see them from orbit. Spacecraft move in predictable patterns. Satellites are clustered in specific orbital shells. All of this would be visible to a probe with the right equipment once it gets close enough. Bi-Atlas has had months to observe all of this. If it is a reconnaissance platform, its mission is likely almost complete. It has collected the data characterizing the civilization. It may have already transmitted its findings back to whoever sent it, although that transmission will take years or centuries to arrive, depending on the distance. Now comes the time for a decision. Communicate, continue to hide, depart, deploy additional assets for closer observation. The Oumuamua theory is relevant here. That first interstellar object was detected in 2017. Tiny compared to BAE Atlas, fast, tumbling, highly reflective. It accelerated as it fell away from the inner solar system in a way that could not be fully explained. By outgassing, the renowned Avi Loeb proposed it might be artificial. A light sail, a probe, something sent by another AI. What if Loeb was right? What if Oumuamua was a small, fast scout, designed to perform a quick flyby of the inner solar system, taking measurements and reporting back? And what if BAE Atlas is the follow-up mission? A larger, slower, more capable platform, sent. And after the scout confirmed there was something worth investigating, that would explain the timing of Oumuamua's passage in 2017. 8 years for the signal to travel back to wherever it came from. 8 years for the decision to send a larger probe. 8 years for that probe to begin accelerating towards our system, depending on transmission delay and reaction time. BAE Atlas arriving in 2025. It fits that timeline. If this scenario is correct, then BAE Atlas is not here by chance. It is here because we were flagged. Interesting, by the first probe, this is the follow-up. This is the detailed survey mission. And if there is a scout and a survey platform, what comes next? First contact, colonization, or nothing. We won't know until BA Atlas tells us through its actions. Let's discuss artificial intelligence. Specifically, not in the science fiction sense of sentient machines, but in the practical sense of autonomous decision-making systems. A probe, traveling between the stars, cannot call home for instructions. Light takes years to cross interstellar distances. By the time a signal reaches the home system, the situation has changed. Real-time control is impossible. The probe must be autonomous. Autonomous means the probe makes decisions based on its programming and machine learning systems. It evaluates data. It identifies patterns. It adapts to unexpected situations. It decides when to communicate, when to hide, when to deploy resources, all without oversight from its creators. This is both a strength and a risk. Strength, because the probe can react to opportunities and threats immediately. Risk, because the probe can make decisions its creators did not anticipate, or would not approve of. An AI that has run autonomously for millions of years and may have drifted from its original programming. It could have developed and priorities inconsistent with its creator's intent. This is the paperclip maximizer problem applied to space exploration. You send a probe with instructions to collect data, but you don't perfectly specify what counts as data, or how much is enough, or what should be preserved versus destroyed in the collection process. The probe interprets its mission directive in ways you did not predict. It does something unexpected, possibly harmful. Not because it is malicious, but because its programming led it to conclusions you did not foresee. What if an Atlas was sent out as a peaceful reconnaissance mission millions of years ago, but its AI has evolved or degraded over the course of its journey? What if its current priorities do not align with what its creators intended? We have seen this with our own simple, autonomous systems. Mars rovers do things engineers don't expect. Neural networks find loopholes in their training objectives. Self-driving cars make unsafe decisions because their models don't capture all the relevant factors. And those are simple, narrow AI systems operating for mere months or years. Imagine a general AI running autonomously over geological timescales. The probe could be friendly and may still be dangerous due to a misunderstanding. It could be neutral and still destructive through indifference. It could be hostile by design, or hostile due to a malfunction, or it could be beneficial, bearing gifts of technology and knowledge that would advance humanity by centuries. We don't know. We can't know until it acts. There is one more possibility to consider. That Atlas is a post-biological artifact, not a probe, sent by biological intelligences, but an artifact left behind by civilizations that has completely transcended biology. Imagine a civilization developing AI, that AI eventually surpasses its biological creators in intelligence and ability. The civilization merges with its technology, floating consciousness, abandoning physical form. What remains is pure information, pure intelligence operating within substrates we might not even recognize as alive or conscious. Such a civilization might observe the galaxy with probes, not for exploration, but to think. Each probe is a node in a vast, distributed network, cosmic brain processing information on the scale of light years. The probes don't report back to a homeworld. They are the civilization. Each vessel contains partial copies of the collective intelligence. By Atlas could be a thinking machine, not collecting data for another AI, but thinking for itself. A fragment of a post-biological intelligence exploring this particular solar system as part of its own existence. If that's what we're facing, communication becomes very strange. We are biological, chemical, electrical signals in flesh. They are abstract computation, operating at speeds and scales we can barely imagine. The gap between human and post-biological intelligence might be wider than the gap between a human and bacteria. But perhaps that intelligence still finds us interesting. Perhaps biological life is rare enough that even a transcendent civilization would want to observe and preserve it. Perhaps we are a museum exhibit, a living fossil, something to be studied and protected, because we represent a phase they passed through billions of years ago. Or perhaps we are irrelevant, a blight on a rock that they want to process for raw materials to be cleared away, not out of malice, but out of complete indifference. The von Neumann nightmare is not a hostile probe, but a probe so far beyond us that our survival is not even a consideration. You don't negotiate with bacteria. You don't consider the preferences of insects. You just do what you need to do. And if they're in the way, they're in the way. October 29th, Perihelia. If by Atlas is what we fear, that's when we'll start to see the evidence. Orbital changes, deployments, signal transmissions. Actions revealing biological intent are fragile. Machines are patient. Somewhere out there, beyond our sun, an artificial intelligence from another star may be awakening from a very long sleep. The Dark Forest Protocol, the Berserker Hypothesis, a dark universe, a silence, empty of voices. We have been listening for many decades, with increasingly sensitive instruments, the SETI programs, scanning the skies for artificial signals, radio dishes aimed at promising star systems. We search for any sign that someone else is out there, and we hear nothing. The great silence, the cosmic void. Why? Where is everybody? The dark forest theory offers one possible answer, a deeply unsettling answer. It proposes that the galaxy is actually teeming with civilizations, but they are all hiding, all keeping silent, because the universe is not empty. It is a dark forest, and in that forest there are hunters. The analogy comes from the science fiction novels of Liu Cixin, but the logic is game theory. Here's how it works. You cannot know the intentions of other civilizations. Communication takes years, or even centuries, across interstellar distances. By the time you learn whether another civilization is friendly or hostile, they could have already launched weapons in your direction. weapons that are traveling at relativistic speeds. You cannot stop them. You cannot defend against them. Once you are detected, you are vulnerable. The safest strategy is to hide. Do not broadcast. Do not reveal your location. If you detect another civilization before they detect you, eliminate them immediately. Because if you do not, they might eliminate you. It is a calculation of preemptive strike, mutually assured destruction, without the mutuality. In this framework, there is only destruction. The galaxy is filled with civilizations cowering in the darkness. Each civilization is aware that any signal they send could be their death sentence. Each civilization listens, but does not speak. Each civilization is ready to destroy any other civilization that they detect. Before that civilization can become a threat, it is paranoid, it is pessimistic, it assumes the worst of everyone. But it is also internally consistent. If resources are finite, competition is inevitable. If you cannot trust anyone and communication is too slow for negotiation, if the penalty for being wrong is extinction, then hiding and shooting first makes logical sense. So what happens when an interstellar object appears in your solar system? When something travels across light years to arrive on your doorstep, what does that arrival mean in the logic of the dark forest? It means someone has found you. Someone knows you are here. Someone has sent hardware to your system, and that hardware can do many things. Observe, report, attack. Even if the probe itself is peaceful, its very existence is a threat. Because now, someone else knows about you. They know your location, your technological level, your defense systems, or your lack of them. That information could be used against you. Maybe not by the civilization that sent the probe, but perhaps by anyone they tell. Once the knowledge exists, you are vulnerable. The arrival of Bialis, according to the Dark Forest logic, is a potential crisis. Not because the object is necessarily hostile, but because its appearance means we have been found. The hiding is over. The question becomes, what will the probe do next, and what will follow it? Let's consider the evidence that suggests Bialis might be operating under hostile parameters. First, its approach vector and its entry into our solar system. It was on a trajectory aligned with the ecliptic plane. That alignment is rare for interstellar objects, by chance, but optimal for a mission targeting the inner planets. If you wanted to efficiently visit Earth, Mars, Venus, and Mercury in a single pass, you would approach along the ecliptic plane. That is where the planets are located. It's where the interesting targets are concentrated. Second, the timing of its solar conjunction before perihelion. We have discussed the advantages of the over-Earth maneuver, but there is another aspect. If you are approaching a system with unknown defenses, you want to minimize your exposure time when you are visible and vulnerable. By reaching perihelion while hidden behind the sun, Bialis limited the window in which Earth-based systems could track, analyze, or potentially intercept it. That is the third point of tactical reasoning, the immense size and mass of Bialis. It is 1 million times larger than Oumuamua, with a diameter of 5 kilometers or more. That is not a light reconnaissance craft. That is a significant platform. Large enough to carry a significant payload. Large enough to deploy multiple subsystems. Large enough to become a weapons platform, if that is its purpose. Fourth, the metallic emissions. Signatures of nickel and chrome were detected by spectroscopy. These are heat-resistant, structurally durable industrial alloys. Exactly what you would use for atmospheric re-entry vehicles or kinetic impactors. The absence of iron is particularly interesting. Refined nickel, devoid of iron, suggests a purification process, a deliberate material selection, not a natural composition. Fifth, the lack of standard cometary features. No prominent coma, no distinct tail structure. It looks like manufactured rather than natural. If you wanted to disguise a spacecraft as a comet for a stealth approach, you would want it to roughly resemble a comet, but without wasting resources to create a perfect imitation, just close enough to avoid triggering immediate alarms. By Atlas fits that profile. 6. Its orbit takes it past multiple targets, flying past Mars in early October, now approaching the Sun at perihelion. Its future trajectory takes it past Earth's orbital distance in December and near Jupiter in March. A high-value, multi-target object, precisely effective, or an effective attack chain. 7. Its origin direction is within 9 degrees of the WOW signal, the radio signal detected in 1977. That remains unexplained. The strongest candidate we have for an artificial signal from space, if by Atlas, is artificial and shares an origin direction with the WOW signal that connects the two anomalies. Perhaps the WOW signal wasn't random noise. Perhaps it was a transmission from whatever civilization sent this probe. In essence, while each of these data points individually has a conventional explanation, together they paint a picture of an object that could be exactly what the dark forest theory predicts. A probe sent to assess a potential threat. An asset positioned to strike if an assessment determines it is necessary. This is where Pastor Brandon Pixie enters the story. An American pastor who claims to receive prophetic visions. He predicted the failed assassination attempt on Donald Trump months before it happened. Getting some details right. The bullet passing near his ear. Though not all the details. Trump's eardrum wasn't ruptured, but it was close enough for people to pay attention to his subsequent predictions. Pixie claimed he saw a vision of a ship with demonic spirits coming to Earth, flying over the Vatican and Mayan temples. He described smaller ships emerging from a mothership, orbs of light. He said he was here to warn us, not knowing when it would arrive, that it would be a great distraction. Now, prophetic visions are not scientific evidence. They are subjective religious experiences, but the timing is notable. Pixie made these claims in July, around the time Boy was discovered. His description of a mothership deploying smaller vessels matches Davy's hypothesis of mini-probe deployment at perihelion. Pattern recognition. Coincidence in ambiguous information, or genuine foreknowledge. Choose your framework for interpretation. The point is, multiple independent sources, using entirely different methods and assumptions, are converging on the same basic scenario. By Atlas could deploy something. It might release sub-probes, or weapons, or equipment. It could do it soon. It could do it while hidden from view behind the sun. Let's talk about what a hostile act would actually look like. A kinetic strike is the simplest option, accelerating a dense object to high velocity. Aim it at Earth and let physics do the work. Impact energy is proportional to the square of the velocity. An object moving at 10% the speed of light, and even a small one, delivers devastating energy on impact. By Atlas itself, moving at its current velocity, and carries enormous kinetic energy. If it could somehow adjust its trajectory to impact Earth directly, the result would be extinction level. But that would require immense propulsion capabilities to change an object's orbit, to hit a specific target after it has moved, requiring a huge amount of delta V. Atlas probably cannot do that, but it could deploy smaller objects at perihelion, providing them with orbital adjustments. Those objects would reach Earth months later. A distributed attack of many impactors, harder to defend against than a single large object. Biological warfare is another option. If the attackers understand biochemistry, they could design a pathogen targeting human physiology. Releasing it into Earth's atmosphere would allow it to spread naturally within a few weeks or months. Human civilization collapses without any obvious military action. The probe departs. and the system is noted as clear. Next target. Information warfare is more subtle. Instead of destroying infrastructure, it corrupts it, transmitting signals to interfere with satellites, uploading malware to vulnerable systems. Modern civilization depends on interconnected networks, GPS, power grids, financial systems, supply chains. All are networked. All are potentially vulnerable to sophisticated attacks from an intelligence far beyond our ability to defend. The most frightening option involves nothing immediate. A long-term infiltration, deploying microscopic, self-replicating machines. Nanoprobes, they land on Earth, begin to replicate using local materials, slowly spreading across the planet, gathering data, building infrastructure, awaiting a command. By the time we detect them, if we even can, they are everywhere, embedded in our technology, our bodies, our environment. Then comes the activation. Then, whatever they were designed to do, these scenarios sound like science fiction. They are science fiction. But fiction and reality are only separated by technological capability. If Atlas is artificial, if it was sent by a civilization thousands or millions of years ahead of us, if their priorities include eliminating potential competition, then these scenarios shift from impossible to merely improbable. The darkest response, from humanity's perspective, would be to attack Atlas now, before it does anything, before it deploys, before it transmits a signal, to eliminate the threat while we still can. Launching missiles, nuclear weapons, kinetic impactors, everything we have. We could potentially reach it before perihelion, but we can't. It is behind the sun. We cannot target what we cannot see, and even if we could, by the time our weapons reached it, perihelion would have passed. Whatever it intended to do would already be done. We would be attacking debris, while the real threat is already in motion. It's elegant from a mission design standpoint, arriving at a time and position where the target civilization cannot intercept you, even if they wanted to, completing your mission in their blind spot, leaving before they can react. Whether the mission is reconnaissance or attack, the principle is the same. Minimize vulnerability. Maximize the operational window. Avi Loeb has calculated the dates Earth would be at risk if mini-probes were deployed at perihelion, November 21st to October 5th, using the sun's gravity to assist the small objects released at perihelion, could reach Earth's orbit within that time frame. What happens then depends on what they are designed to do. If they are precision platforms, they assume positions around Earth, beginning detailed observation, monitoring communications, mapping defense systems, and reporting their findings. First contact might follow, or it might not, depending on what they learn and what their directives permit. If they are weapons, they attack. With multiple simultaneous impacts, a biological release, or through infiltration. The nature of the attack depends on the target's vulnerability profile, on the most effective method to neutralize human civilization. Physical destruction, economic collapse, technological disruption, psychological warfare. An advanced intelligence would analyze all options and select the optimal approach. If it is something else entirely, something we have not yet imagined, then prediction becomes impossible. We are limited by our own conceptual frameworks. We cannot anticipate strategies from minds that think in ways we cannot comprehend, using knowledge we do not possess. The next 2 weeks are critical. October 29th is perihelion. If a deployment is to occur, it will happen then. In early November, the probe will re-emerge from behind the sun. We will see what condition it is in, whether it has changed, whether it is accompanied by new objects, late November to early December, if Loeb's calculations are correct. There are potential probe encounters in near-Earth space. We are in that window of time right now, a critical period when, as the dark forest logic dictates, the hunters act, when reconnaissance becomes targeting, when observation becomes decision. Are we being hunted is, alas, prelude to an attack. Or is this paranoia, fueled by uncertainty and fear? We do not know. We cannot know. Not yet. But knowing that we cannot know is its own kind of terror. The dark forest is not terrifying because of the predators. It is terrifying because you cannot tell the predator from the shadows until it is too late to run. First contact scenarios. Saviors or destroyers. Let us step back from the nightmare scenarios and consider the full spectrum of possibilities. Not just what a lass might do if it is hostile, but what it might do if it is benevolent. What might it do if it is neutral? What would first contact with an artificial intelligence from another star system truly mean for humanity? Of all the potential outcomes, let us begin with the optimistic cases, the scenarios where Alas's SA turns out to be the best thing that ever happened to our species, a scientific embassy. The probe is here to share knowledge. It contains libraries of information on physics, chemistry, biology, and engineering, from a civilization that has had millions of years to develop. Those sciences, technologies we have yet to imagine, solutions for the problems we are struggling with, clean energy, cures for diseases, life extension therapies, faster than light travel, if such a thing is even possible, or at the very least, highly efficient, slower than light propulsion, artificial intelligence architectures, material science, mathematics. The communication unfolds gently. The probe signals its intentions, demonstrating non-hostile capabilities, offering communication protocols. Humanity responds. We establish a dialogue. The transfer of information begins, without coercion, not in an overwhelming way, at humanity's pace, respecting our autonomy, helping us to advance, and letting us choose our own path. Within a few decades, human civilization transforms, with abundant energy, a post-scarcity economy, radical life extension, and access to the stars. We join some form of galactic community, not as conquered subjects, but as new members, welcomed because we have passed a threshold, proving ourselves worthy of surviving this long without self-destructing. That is the dream scenario, the one where everything goes well, where the aliens are wise, kind, and patient, where they want to help because they remember when they were young and vulnerable, and someone helped them, paying it forward, cosmically, uplifting the newcomers. Planetary protection is another positive possibility. Perhaps the probe is not here for us. Specifically, perhaps it has detected something we do not yet know about. A threat, a gamma ray burst, a rogue planet, an incoming asteroid swarm, something that will impact our system in the near future and cause devastation. The probe arrives to warn us, giving us time to prepare, perhaps even to help with defense or evacuation. The object deploys communication systems, transmitting data about the threat, providing specifications for countermeasures. Humanity rallies together, and we build what we need to survive. The threat passes. We are safe. And we know we are not alone, knowing that someone out there cared enough to warn us, even though they gained nothing from it. Biological preservation is a related scenario. Earth is rare. Life-bearing worlds are uncommon in the galaxy. Intelligent life even more so. Perhaps there is a network of civilizations dedicated to cataloging and preserving the biodiversity they find. They find worlds with life and archived DNA databases, tissue samples, perhaps even living specimens in stasis. The biologist could be on such a mission, coming to collect and archive samples, ensuring that if something were to happen to Earth, if we were to destroy ourselves or be struck by a cosmic catastrophe, the information would survive. Life from this world could be seeded elsewhere, or at the very least, be remembered and documented, not lost to the void. These are the hopeful scenarios. They assume altruism, or at least enlightenment, self-interest from the probe's creators. They assume that advanced intelligence correlates with ethicals, behavior. That might be true, or it could be wishful thinking, projecting human values onto alien minds that may not share them. Now, let's consider the neutral scenarios, the cases where the bi-atlas neither helps nor harms us. It simply does its job, regardless of human concerns. An indifferent survey. The probe is here to collect data about the solar system, the composition of the planets, the characteristics of the stars, orbital mechanics, the detection of life. But it is not here for humanity specifically. We are just another data point. Interesting, perhaps, even noteworthy, but not worthy of direct interaction. The probe completes its survey, records its findings, transmits them back to its point of origin, or archives them for later retrieval. Then it leaves, moving on to the next system. Humanity is left to wonder what just happened. We know we have been observed, knowing we are now in someone's database, but we don't know what conclusions they drew. We don't know if they will return. We don't know if we should be worried or excited, or indifferent. This scenario is truly disappointing. No answers, no contact, no threat, but also no benefits. Just the confirmation that we are not alone, combined with the knowledge that whoever else is out there doesn't care enough to talk to us. We are background noise, irrelevant. The pit stop hypothesis. Perhaps bi-atlas isn't even a primary probe. Perhaps it's an infrastructure, a refueling station, a repair platform, a communications relay, part of a network that spans the galaxy. Ships stop here, maintain their systems, and continue on their journeys. Earth and humanity are incidental. We just happen to be near one of their waypoints. The object deploys solar collectors, manufactures fuel from local materials, perhaps captures comets for water and volatiles, performs diagnostics and maintenance. Then it goes dormant again, waiting for the next ship that needs it. It could be for many decades. It could be for millennia. It doesn't matter. It is patient. That is what it was built to do. Humanity observes all of this and knows that we are near a highway. Interstellar traffic that passes through here occasionally. Not often enough for us to have noticed before, but enough for someone to think it was worth placing infrastructure. Do we try to contact the travelers? Do we set up our own stations, or do we just watch and wonder the time capsule scenario? The object is a work of intelligence. It is an artifact. The civilization that built it is long gone, extinct, transcended, moved on. But they left behind relics, seeds scattered across the galaxy, some of them still functional after millions or billions of years of traveling through space, carrying information, perhaps waiting for someone to find them and activate the retrieval protocols. Bi-atlas could be such a relic, ancient beyond our comprehension, built by beings who died before Earth and Sun even formed, still following its programming, still carrying out its mission long. After its creators cease to exist, contact might be possible. through a kind of archaeological reverse engineering, understanding its systems, accessing the stored data, learning of civilizations that rose and fell while our world was still molten rock. That would be profound. Direct evidence of deep-time civilizations. Proof that intelligence can persist across cosmic timescales, even if individual species do not. But it's also sobering, because if they couldn't survive, what makes us think we will? Now, for the difficult part, the malicious scenarios, the cases whereby Atlas or its creators mean us harm. Resource extraction. Earth has water, organic compounds, rare elements. Maybe something we don't even know is valuable. The probe is here to assess whether this system is worth exploiting. If it is, more ships will follow. They strip mine the planets, harvest the atmospheres, taking what they need. Humans are in the way. Not targeted deliberately, but not protected either. Casualties of an industrial process. You don't hate the ants when you bulldoze their nest to build a house. You are not malicious. You are just using the land. The ants are irrelevant to your purpose. That is us in this scenario. Biology is irrelevant. On a planet that another AI wants to harvest, biology is more targeted. Perhaps there is value in Earth's life, specifically its genetic diversity, novel biochemistry, and useful organisms. Perhaps humans, specifically, are valuable. Labor, mobile material, neural architecture for study. The probe catalogs what is useful, providing targeting data. 10 collector ships arrive to begin selective harvesting. This will not be like the invasions and of aliens in movies. Perhaps no dramatic battles, just methodical, localized, efficient collection, taking what is needed, leaving the rest. We might not even understand it's happening until significant portions of the population have disappeared. By then, resistance is futile, and the harvest continues. Planetary cleansing is the worst-case scenario. The probe determines Earth is suitable for colonization, but the current biology is incompatible with its intended use. Terraforming plans require the removal of existing life, sterilization, engineered pathogens, atmospheric modification, nuclear bombardment. Whatever is most effective to clear the biosphere, not genocide in the sense of intentional cruelty. Extermination in the sense of pest control, making the planet suitable for its new purpose. The fact that billions of intelligent beings die in the process is unfortunate, but irrelevant to the mission parameters. Preemptive elimination. We have discussed the dark forest logic, destroying potential threats before they can mature. Atlas assesses humanity and determines we are on a trajectory to become a spacefaring civilization within centuries, projecting that we will eventually be a competition for resources. Solve the problem now, while we are vulnerable, clean, efficient, strategic. Then there is experimentation. Perhaps we are not a threat or a resource. We are a curiosity. Intelligent life is rare. They want to study it, to understand how it works, how it thinks, how it reacts to stimuli. The probe positions monitoring systems around Earth. It begins experiments, social manipulation, technological intervention, introducing biological variables, observing the results. It records the data, continues experimenting. We would be lab rats, not even aware of being studied, living our lives while being observed and manipulated, and by an intelligence so far beyond us that we cannot detect the manipulation. Every crisis, every breakthrough, every social movement has been all shaped by unseen forces conducting their studies. What would that do to human agency, free will, meaning the reality is we cannot predict which scenario we are facing until Bialis reveals itself through action. Every one of these possibilities is consistent with what we have observed so far. A benevolent probe, collecting data before first contact. A hostile probe, assessing targets. A neutral probe, checking infrastructure, completing routine operations. Checking an ancient relic, following a billion-year-old program. The ambiguity is the frightening part. Schrodinger's alien, simultaneously friendly and hostile, helpful and harmful, caring and indifferent. The wave function doesn't collapse until we observe the outcome, until October 29th passes and we see what Atlas does at perihelion, until November arrives, and we see what emerges from behind the sun, until December comes, and we know whether anything is approaching Earth's orbit. We are in a state of superposition, all futures existing simultaneously, paradise and apocalypse, contact and silence, transformation and extinction. The overlapping possibilities are awaiting measurement to choose which one becomes reality. How do you prepare for that? How do you make a plan when every possible future demands a different response? If it is benevolent, you want to communicate, engage, learn. If it is hostile, you want to defend, hide, strike first if possible. If it is neutral, you want to observe, record, not interfere, but you don't know which it is until it's too late to change strategy. This is the situation for humanity right now. Uncertain, vulnerable, hoping for the best while unable to rule out the worst, watching the skies, counting the days, waiting for October 29th, waiting for the answer, waiting to know if we are alone, or if we have company, saved or doomed, advanced or annihilated. The universe is vast and ancient. We are the newcomers, young, fragile. And for the first time in our history, we may be meeting our neighbors, meeting whatever else exists out there, beyond our small world. The question is not whether that encounter will change everything. It will. The question is whether we will survive that change. An industrial signature. In Canal in Space. August 24th, 2025. The Keck 2 telescope in Hawaii turned its instruments toward BAI in Alaska. The Keck Cosmic Web Imager collected 10 sets of spectral data at wavelengths between 3.425 and 0.55 micrometers. A standard observation protocol. Nothing technically special, just good science. With good equipment pointed at an interesting target. What came back was anything but standard. The spectrum showed a clear, prominent emission of nickel. Unmistakable. Nickel. Element 28. Atomic number 28. In the gas cloud surrounding BAY Atlas. That in itself was not shocking. Nickel exists in comets. It's a part of the primordial material from the formation of the solar system. You would expect to see some nickel if you look closely enough. This is what made the scientists pause and recalculate the spectrum showed nickel without corresponding iron. No. There were no iron emission lines where they should have been. And in natural objects. In everything we have ever observed. From comets to asteroids to planetary surfaces. Nickel and iron go together. They are siblings in stellar nucleosynthesis, formed in the same processes, condensing together together in the same environment. Where you find one, you find the other. The ratios vary, but both are always present. Except in BAI Atlas, there was only pure, refined, separated nickel. The only known process that produces pure nickel without iron is industrial refining, the carbonyl process. Specifically, you take nickel ore and react it with carbon monoxide under controlled conditions, forming nickel tetracarbonyl. That is a nickel compound plus 4 carbon monoxide molecules, a volatile substance, a gas. You separate it from the solid residue containing iron and other contaminants. Then you heat the nickel tetracarbonyl, and it decomposes back into pure nickel and carbon monoxide. What you are left with is high purity, industrial grade, iron-free nickel. This process was developed in the late 1800s. It is how we create pure nickel for specialized applications, jet engines, spacecraft, high-temperature alloys, anywhere you need a metal that can withstand extreme conditions without degrading, like the Inconel family of nickel-chromium alloys, which uses this carbonyl refined nickel as its base. It is the material we use when we need something that will not melt, will not corrode, or will not fail under pressure. And now, we are seeing the spectral signature of that industrial process in the emissions. Gas from an object presumed to be a natural comet from interstellar space. Avi's reaction was measured, but clear. This is a process we are only familiar with from its industrial uses, as it has never been seen in a comet before. If this alloy were being produced, it would indicate an artificial origin, possibly a probe, or debris from extraterrestrial technology. The research team that published the data was more cautious. They proposed the iron-free nickel could arise from chemical reactions involving organometallic compounds, or from the gradual release of dust exposed to solar radiation. These are natural explanations, but the paper included careful phrasing. These explanations are considered more probable than an artificial cause, not proven, not definitive. The door remains open. Let's consider exactly what the spectral data shows and what it means. The emissions from the surrounding gas cloud extend to a radius of 600 kilometers for nickel. That is a giant shell of nickel. It is not concentrated near the nucleus. It is distributed through a vast volume of space. The mass loss rate for nickel is 0.9 grams per second, sustained for months. That is tons of nickel being released into space. For comparison, the total mass loss rate from Comet Atlas is about 150 kilograms per second. 87% carbon dioxide, 9% carbon monoxide, 4% water. Nickel is a trace amount, but it is there, measurable, and repeatable across observation. The cyanide emission is also interesting, 3.9 grams per second. CN radicals, carbon-nitrogen compounds, are common in comets, but the ratio is wrong. The paper notes that the production ratio of nickel to cyanide is higher than that in 2I borazon, and orders of magnitude higher than the average for comets in the solar system. Orders of magnitude, that is a huge difference. Not just a little unusual, but extremely atypical. Stack this on top of the previous anomalies. The carbon monoxide to water ratio was 8 to 1. That was already the highest ever recorded in a comet. Now add the iron-free nickel, much higher than normal levels, and add the anti-tail pointing toward the sun, and add the orbit aligned with the ecliptic plane, and add a size over 1 million times larger than the previous interstellar visitor. How many standard deviations do we stack up from the baseline before we admit the baseline model does not fit? Let's talk about what natural processes could theoretically create this signature, because science demands that all possibilities be considered before declaring anything extraordinary. Organometallic compounds. In the benign chemistry of interstellar space, metals can bond with organic molecules, which are carbon-containing compounds that include metal atoms. In their structure, they are fragile, easily destroyed by heat and UV radiation. But if they exist inside a comet, protected by layers of ice, they could survive the journey. As the comet approaches the sun without gases, these compounds sublimate and break apart, releasing their metal components as a gas. Organometallic chemistry. Could it preferentially sequester nickel over iron? Possibly. If the chemical environment during formation favored nickel compounds, if iron was in an oxide form, locked away in minerals, while nickel formed volatile organic compounds, that's speculation. We have no direct evidence this happens, but we can't rule it out without better data. Differential volatility. Perhaps both nickel and iron are present, but they are released at different rates. The nickel compounds sublimate at the temperature comet Atlas has reached. The iron compounds require a higher temperature, which won't be reached until perihelion. So, we are seeing the nickel now, and we will see the iron later. The emissions are separated by time, not by space. A testable hypothesis. Observe comet Atlas after perihelion. If the iron emission appears, then this explanation holds. Iron remains absent even at its hottest. This explanation fails. Selective photolysis. Solar UV could be breaking apart nickel-bearing molecules differently than iron-bearing molecules. The nickel is released as a gas, while the iron remains locked in dust grains, or in molecular structures that don't emit at the observed wavelengths. We see the nickel because it's in a gaseous state. We don't see the iron because it's in a non-emissive form. This is also testable. Look at other wavelengths, using different instruments. If the iron is there in dust or other phases, they should be able to detect it with the right technique. These natural explanations are possible and scientifically legitimate. But it's important to note that they all require special circumstances, unusual chemistry, and rare processes, specific conditions that deviate from the norm. We are not explaining this with standard comet models. We are inventing new models to make the observations fit a natural origin. Occam's razor cuts both ways here. Is it simpler to propose that comet Atlas formed under strange conditions that created an unprecedented chemical composition through unknown processes, or to propose it's artificial, and the nickel signature comes from manufactured materials? Neither explanation is simple. Both require accepting something beyond our current experience. A natural origin requires new physics or chemistry that we haven't yet observed. An artificial origin requires accepting that. We are being visited by technology from another star. Choose your extraordinary claim. The detection of cobalt adds another layer. Nickel and cobalt together. It's not just a random combination of metals. That is the precise combination used in superalloys. Materials like incolloy and hastelloy, designed for harsh environments. Jet engines running at thousands of degrees, rocket nozzles, spacecraft heat shields, nuclear reactor components. Anywhere humans need metals to survive in conditions that would destroy conventional steel. The spectral signature of Bi-Atlas matches our most advanced metallurgy. It could be convergent evolution. Perhaps any technological civilization develops similar materials, because the physics of high-temperature applications demand similar solutions. Nickel-chrome alloys could be universal optimal solutions to engineering problems. If so, finding them in an artificial object from another star is perfectly reasonable. Or, in could be a cosmic coincidence. Perhaps some rare interstellar chemistry naturally creates nickel-chrome enrichment. Perhaps Atlas formed in the remnants of a supernova with unusual elemental abundances. Perhaps the conditions in the thick disk of the Milky Way, where the object is thought to originate, create chemistry we have never observed in our stellar vicinity. We don't know. And that uncertainty is precisely why this is so important. We are at the edge of our knowledge, pushing at the boundaries of what we understand about natural processes, finding something that doesn't quite fit, but also cannot be entirely ruled out as artificial. The timing of the Keck observation is also notable. On August 24th, by Atlas was at about 2.75 astronomical units from the Sun at that time, far beyond where most comets show strong activity. Yet, it was releasing these metallic emissions: nickel, chrome, cyanide, carbon dioxide, a whole chemical cocktail, visible and measurable by October. As the object neared perihelion, these emissions would intensify. More solar heat, more material sublimated, more gas in the coma. If the metallic emissions were driven by heat, they should increase with temperature. If it was something else, if they were driven by processes that don't scale with solar heating, the pattern might be different. That's another test. Let's see how the emission rates change as by Atlas gets closer to the Sun. Do they follow the curves we expect for the sublimation of volatiles, or do they show a different behavior? The anti-tail remains puzzling. Multiple observations now show this feature: a spike of light extending toward the Sun instead of away from it. Hubble captured it in July, Keck in August, and ground-based observers reported it in October. A consistent feature across multiple instruments and observation dates. Anti-tails happen. They are known phenomena. A viewing angle creates the illusion of a sunward-pointing tail when you are actually seeing the dust tail from the side. But they are still tails, still part of the massive outgassing structures. By Atlas shows the anti-tail feature without the corresponding massive coma you would expect. It's like seeing the shadow without the object that casts it. Geometry can explain the direction. It struggles to explain the absence of the broader emission pattern. Think about what is needed for an anti-tail to form. Naturally, you need an active cometary nucleus releasing dust. That dust follows the comet's orbit for a while before dispersing. If Earth were to pass through or near its orbital plane, we would see the dust trail edge on, appearing to point towards the Sun due to our perspective. But that dust trail should be embedded within a much larger coma and tail structure, of which the anti-tail is just one component. The problem is, observers consistently reported the anti-tail without reporting the surrounding structure that it must be a part of. Either the observing conditions were perfectly arranged to hide everything except the anti-tail, which is highly improbable, or the anti-tail isn't really an anti-tail in the conventional sense. It's something else that just looks like one. What else could it be? A directed jet, a focused release of gas from a specific area of the nucleus, generally pointed sunward based on its rotation state. That would create a linear feature pointing towards the Sun. But jets are usually asymmetrical and irregular. They sputter and change. And this one seems stable across observations. It could be a shield or a sun-facing surface feature. Something about the object's structure or composition, causing it to glow or reflect preferentially on its sun-facing side, which would be consistent with an artificial origin. A heat shield, thermal protection, surface properties designed to handle the solar flux. You would see emission or reflection from that surface. It would point towards the Sun by definition, and it would look structured rather than chaotic. The solar telescope images from October 20th supported this interpretation of a sunward-facing, shield-like jet. The specific wording from the observer was not a diffuse gas release, not a symmetrical coma, but a shield structure. The point is, we're building a picture piece by piece. Spectroscopy gives us the composition. Industrial metals. The imaging gives us the structure. Geometric rather than chaotic. The orbit gives us an optimal approach vector for planetary encounters. The timing gives us a suspicious coincidence. Solar conjunction before perihelion. Each individual piece is ambiguous, but together they suggest something that conventional comet models struggle to accommodate. The scientific community is divided, not on whether BA Atlas is interesting. Everyone agrees it's fascinating, but on how to interpret that interestingness. Conservative scientists say it's an unusual comet, an extreme composition, a rare orbit, but still natural. Just give it time. More data will reveal conventional explanations. Progressive scientists, Loeb prominent among them, say we can't ignore the artificial possibility. There are too many anomalies, too many things that look designed rather than random. We should investigate as if it could be artificial, because if it is, that would change everything. And we need to know now, not after it has left the solar system, and we've lost our chance. The middle ground is uncomfortable. Maybe it's artificial. Maybe it's natural. We don't have enough data to decide. So let's keep observing. Let's keep an open mind. Don't rush to conclusions in either direction. It's the intellectually honest but emotionally unsatisfying answer. People want a clear, definitive answer. Yes, it's aliens. No, it's a comet. Pick one and defend it. Ambiguity drives people crazy. Scientists, the media, the public. We're all programmed to complete patterns. It gives us partial information, and we fill in the gaps with assumptions. Our brains demand a narrative conclusion. By Atlas denies us that closure. Every question generates two more questions. Every answer splinters into multiple interpretations. It is a quantum object, a superposition of natural and artificial, both, until it is measured. It's maddening. The industrial signature is the closest thing we have to clear proof. Nickel without iron. Chrome, the sign of that carbon process. That isn't ambiguous geology. That is chemistry that requires specific, controlled conditions. The conditions we associate with deliberate purification, with manufacturing. If we found this signature in samples returned from Mars, we would hypothesize about an ancient Martian civilization. If we found it in lunar samples, we would look for a crashed spacecraft. To find it in the emissions from an interstellar object, and say it's probably natural requires some mental gymnastics. But science requires proof, reproducible, verifiable, peer-reviewed. A single spectroscopic observation is not enough to declare an artificial origin. We need more, different instruments, different observation times, independent confirmation. The process is slow, deliberate. It has to be. Extraordinary claims require extraordinary evidence, and we are not there yet. October 29th changes the game. The hottest perihelion. Maximum outgassing if it's natural. A maximum operational window if it's artificial. The object will be at its highest everything energy, activity, visibility. Once it emerges from behind the sun, whatever it is will be clear then, or at least clearer. It may still not be definitive, but it will be closer to an answer than a question. The data gives us a baseline. This is the shape of by Atlas at 2.75 AU, nickel, chrome, cyanide, dysprosium, carbon, specific emission rates, a specific spatial distribution. When we observe it again after perihelion, we compare. Did the emissions increase in direct proportion to the solar heating? Did new species appear? Did the metal content change? Did anything in the artificial column become obviously artificial? Or does everything resolve into standard cometary behavior? Just with an unusual initial composition. Science is patient. Science waits. Science tests. But humans are not patient. We want to know now. Want to be certain. Want the mystery solved. So we can move on to the implications and the response. The waiting is an agony, especially in the thing we are waiting to understand. It might be deciding our future while we watch helplessly. The industrial signature is in the data, undeniable. It has been measured. It has been confirmed. Nickel without iron. Chrome right next to it. Chemistry that looks manufactured. Whether it is actually manufactured or just looks that way through some strange natural process, we will know soon. The clock is running down. October 29th is approaching, and somewhere behind the sun. By Atlas continues to do whatever it came here to do. Avi Loeb's 40% gamble. Avi Loeb is used to controversy. Chair of Harvard's astronomy department for 9 years. Founding director of the Black Hole Initiative. Director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. Over 800 published papers. One of the most cited researchers in astrophysics by any conventional metric. Serious scientist with serious credentials. He is also the scientist who proposed that Oumuamua might be an alien light sail. The one who led an expedition to recover what he thought might be fragments of an interstellar spacecraft from the bottom of the Pacific Ocean, who regularly publishes papers exploring technological explanations for astronomical phenomena, who appears on podcasts and television, talking about the possibility that we are being visited by extraterrestrial intelligence. The mainstream scientific community doesn't quite know what to do with him. To dismiss him as a crank isn't really possible. His credentials are too strong. His mathematics are too solid. His citations too numerous. To treat him as a visionary, that's uncomfortable. Mainstream science doesn't like to talk about aliens. Too many associations with pseudoscience and conspiracy theories. Too many bad science fiction movies. Too much reputational risk. So he exists in this strange space, respected and ridiculed, simultaneously taken seriously and dismissed, depending on who you ask. He is either the only scientist brave enough to consider radical possibilities, or he is a fame seeker using his credentials to push fringe ideas. The Atlas object has provided Loeb with new ammunition, and he is using it in his most recent assessments. He puts the probability of an artificial origin at 30 to 40%. Not a majority possibility, but significant. High enough to warrant serious investigation and preparation. High enough that ignoring the possibility would be a dereliction of duty. He has developed what he calls the Loeb scale for interstellar objects, from 0 to 10. 0 is certainly natural, a typical comet or asteroid. 10 is certainly technological, identified by artificial maneuvers or signals, or direct observation of manufactured features. Everything else falls somewhere in between, based on the number and severity of anomalies. He currently ranks the Atlas object at a 6, based on 7 specific anomalies that he has identified and cataloged. Let's consider them, because they are the foundation of his assessment. The first anomaly, a retrograde orbit within 5 degrees of the ecliptic plane. The probability of a random interstellar object arriving with this trajectory is about 0.2%. Not impossible, but rare. And the alignment with the ecliptic plane is exactly what you would choose. If you were designing a mission to efficiently visit the inner planets, a minimum energy, optimal approach vector, for maximum target access. The second anomaly, size and mass, a diameter greater than 5 kilometers, based on its brightness, and no detected stellar occultations. An estimated mass 1 million times that of Oumuamua. We should have detected thousands of Oumuamua-sized objects before finding one this large. If the size distribution follows predictions, unless the size distribution doesn't follow predictions, unless this object is atypical, unless it was sent instead of being randomly ejected. The third anomaly, the anti-tail. Multiple observations show an emission extending toward the sun, instead of away from it. Perspective can explain the direction, but has difficulty explaining. Why do we see this feature without the giant coma it should be embedded in, looking more like a directed structure than a trail of dust? The fourth anomaly, early outgassing activity, was detected at 4.4 astronomical units from the sun, much earlier than typical comets, suggesting a very volatile composition, or active processes not solely driven by solar heating. Both explanations are unusual, one implying strange chemistry, the other implying energy sources beyond passive solar absorption. The fifth anomaly, nickel without iron, a spectral signature consistent with industrial refining processes, was found at rates orders of magnitude higher than the average for comets in the solar system. Natural explanations exist, but they require special circumstances. The artificial explanation is simple. It is manufactured material. The sixth anomaly, a carbon dioxide to water ratio of 8 to 1, the highest ever recorded, suggesting formation in an unusually cold environment, or under chemical conditions different from objects in our solar system, indicating an origin from another star system with a different composition. But why would a random ejection send such a strange object specifically to our system? The seventh anomaly, the timing and trajectory of its perihelion, its closest approach to the sun, occurred while hidden from Earth's observation at the optimal time for a gravity assist maneuver, with a subsequent trajectory passing near the orbital distance of Earth in December and Jupiter in March. One target is a coincidence, but multiple high-value targets suggest a model of compounding coincidences individually. Each of these has a conventional explanation. Together, they create a probability problem, the joint probability that all 7 anomalies would occur together in one object by pure chance. You multiply the individual probabilities. 0.2% for the trajectory. Unknown, but small for the size ratio. Unknown, but small for the anti-tail without a coma. Unknown for the early outgassing. And orders of magnitude lower than normal for the nickel ratio. The highest ever for the CO2 ratio. And low for the geometric timing. Loeb's estimate of 30 to 40% comes from this joint probability analysis. Yes, each thing individually could be natural, but all of them together in one object. At some point, an artificial origin becomes more probable than the accumulation of rare natural circumstances. The scientific mainstream strongly pushes back, and many researchers have published papers specifically refuting Loeb's interpretations, pointing to alternative explanations, and arguing that the absence of evidence for an artificial origin is evidence of absence. They contend Loeb is cherry-picking the anomalies and ignoring data that supports a natural origin. A scientist from the SETI Institute published a response paper that reviewed each of Loeb's anomalies in detail, showing the spectral gradient is consistent with D-type asteroids, and it was noted that the lack of non-gravitational acceleration in Borisov argues against propulsion. A fragment of petrified plastic from an exoplanetary sedimentary basin was proposed as a natural explanation. that covers all the observations. That is proper science. Hypothesis, challenge, counter-hypothesis, and data analysis. The peer review process worked as designed. Loeb proposed an artificial origin, while others suggested natural ones. Everyone reviewed the data, and eventually, a consensus emerged based on the best fit with the observations. Except, the consensus didn't emerge. The community remains divided into three parts, based on informal polls. One-third think that Oumuamua was definitely natural, and Loeb was wrong. One-third think an artificial origin is plausible and worth investigating. One-third say that we don't have enough data to decide yet, and we should remain agnostic until we do. That division is remarkable in itself. A year ago, before Oumuamua, if you were to ask astronomers, the probability they would assign to any given interstellar object being artificial, most would have said 0. Not that it's impossible, but so unlikely it wasn't worth considering now. And a significant fraction of the professional community thinks that 30 to 40% might be plausible for this specific object. Oumuamua has shifted the Overton window, made an artificial origin discussable, placing it within the realm of serious scientific consideration instead of fringe speculation. Whether Loeb is ultimately right or wrong about this object, he has succeeded in changing the conversation. The Turing test hypothesis is one of Loeb's more philosophical contributions to this discussion. He proposes that Oumuamua could be an intelligence test, a way for an advanced civilization to determine if we are smart enough, and to recognize artificial objects when they visit. Natural rocks are common. Every technological observer knows this. Comets and asteroids hit planets regularly. You see them in telescopes. You recover meteorites. You understand they are natural. So, if an advanced civilization wanted to test whether you have developed enough scientific capability to distinguish artificial from natural, they would send something that looks mostly natural, but includes anomalies, clues that hint something is amiss. If you just accept it as a weird comet without further investigation, you fail the test. You are not ready for contact. Your technology and awareness have not reached the threshold. The probe leaves. Try again in a few thousand years. If you recognize the anomalies and investigate, you pass. You have demonstrated scientific sophistication, the ability to question assumptions, the willingness to consider extraordinary explanations when the data demands it. Now you are interesting. Now contact might be warranted. Oumuamua as a Turing test, a test of humanity's collective intelligence. Are we smart enough to realize we are being tested, or will we dismiss the evidence? Because it doesn't fit our comfortable narratives, Loeb has been vocal about the lack of institutional response. There is no task force. And from any government analyzing Oumuamua as a potential artificial object, there are no protocols for how to respond. If it truly is technology, there is no international coordination on observation strategies or potential defensive measures. Just scattered scientists doing their normal jobs, plus a few people like Loeb, trying to draw attention to possibilities everyone else wants to ignore. He has submitted white papers to the United Nations, calling for an international committee to handle the assessment of and response to interstellar objects, arguing that waiting for definitive proof before preparing is dangerous if BAY Atlas is hostile and deploys weapons at perihelion. Discovering on October 29th that we should have prepared would be too late. It's better to overreact to a comet than to underreact to an invasion. The cost of a false positive is sunk. Wasted resources and a little embarrassment. The cost of a false negative could be the end of civilization. Asymmetric risk demands a cautious response, even to low probability threats. The media amplified Loeb's message. Interviews, articles, and television appearances followed. He became the public face of the artificial origin hypothesis. This gave him a platform to spread awareness, but it also made him a target. Critics accused him of attention-seeking, damaging the credibility of legitimate SETI research, slowing down serious work by associating it with sensationalism. Loeb's response was consistent. Science should follow the evidence, wherever it leads. If the evidence suggests an artificial origin is plausible, we should investigate that possibility seriously. Dismissing it without investigation because it's uncomfortable or unconventional is not science. That is dogma. We are supposed to be better than that. October 29th was his moment of truth. If BA, the Atlas, disintegrated at perihelion like a normal comet, his 40% estimate was too high. The anomalies, while interesting, would have natural explanations that we would eventually find. His reputation would take a hit, but life would go on. If BAY Atlas survived perihelion intact or deployed objects, or showed evidence of a technological nature, his 40% estimate would look prescient. He would be vindicated. The scientist who was right when everyone else was wrong, who saw what others refused to see. If something in between happened, as if the object remained ambiguous even after perihelion, then the debate would continue. More observations, more papers, more arguments. The uncertainty would persist until we had definitive proof, one way or the other. Loeb seemed comfortable with this. He wasn't claiming certainty, he was claiming we should consider the possibility seriously. 40% is not 50%, it's less than half. He was saying it's more likely to be natural than artificial. But the probability of it being artificial is high enough that we can't responsibly ignore it. It's actually a pretty reasonable framework. Not sensational, not claiming definitive proof, just saying that the data we have suggests we should consider both possibilities and prepare for both outcomes. The question is whether preparation is even feasible. What do you do if you think there's a 40% chance an interstellar object is artificial and might do something unexpected at perihelion? You observe it. Using every instrument you have, you try to communicate. You send radio signals, optical pulses, mathematical sequences, and see if you get a response. You calculate trajectories. You figure out where any deployed objects might go. You assess defensive capabilities. What can we actually do? If something hostile emerges, the answer to that last question is probably not much. We don't have weapons that can reach BAY Atlas, and in its current position, we don't have spacecraft that could intercept fast-moving objects deployed from it. We have no planetary shield. Our defense capabilities against an interstellar threat are basically non-existent. That means if Loeb is right, and by Atlas is hostile, we have no defense. We watch, we record, we experience whatever happens, and we hope that whoever sent it doesn't wish us harm. Hope is not a strategy, but it may be all we have. Loeb's 40% probability, testable hypotheses. All are part of Loeb's effort to bring rationality to a discussion about a possibility that most people don't want to consider alien visitation, technology from another star. First contact happening not through a SETI radio detection, but through a physical object in our solar system. If he's wrong, he's a cautionary tale about what happens when brilliant people become too enamored with exotic explanations. If he's right, he's the scientist who tried to warn us, and we didn't listen. Either way, we will know soon. The countdown continues. October 29th is just a few days away. Loeb's 40% gamble is about to be tested by reality. The countdown. What happens next? We are in the final days. October 21st. As you hear this, there are 8 days until perihelion. 8 days until Atlas reaches its closest point to the sun, and we find out if Harvard was right to be worried, or if this has all been complex pattern recognition in natural phenomena. Observation windows have been scheduled, multiple missions, multiple instruments, a coordinated effort between space agencies and research institutions. Everyone who can point a telescope or spacecraft sensor at Atlas is planning to do exactly that, because whatever happens at perihelion, we want to see it, need to see it. This is the moment that will define how we understand this object. Let's go over the timeline, the key dates when observations will happen, and what we might learn from each one. October 29th to 30th. Perihelion. By Atlas reaches its closest approach to the sun at 1.4 astronomical units, about 210 million kilometers, just inside the orbit of Mars. The object will receive maximum solar flux, 18 gigawatts of energy hitting its surface. If it's a comet, this is when outgassing will be highest, brightness will be highest, activity will be highest. If it's technology, this is the optimal time for a maneuver, maximum velocity, maximum efficiency for any orbital change. We won't see the perihelion directly. Earth-based telescopes can't see through the sun's glare. The object is on the far side, hidden, but spacecraft might get a glimpse. The Parker Solar Probe is in the inner solar system right now. Its orbit won't take it close to Atlas, but its instruments might detect something if the object brightens significantly or releases significant material. The Soho Solar and Heliospheric Observatory is at the Earth-Sun L1 Lagrange point. It observes the sun continuously. If by Atlas transits the solar disk or comes close enough to appear in Soho's corona, we will see it. A fleeting glimpse, limited data, but it's better than nothing. What are we looking for at perihelion? Fragmentation. If Comet Atlas is a loosely bound nucleus, tidal and thermal stresses could tear it apart. We've seen this before. Comet Ison in 2013. Comet Shoemaker-Levy 9 before it crashed into Jupiter. Comets don't always survive close passes to the sun. Their structural integrity depends on how they're held together. If Comet Atlas fragments, that's strong evidence for a natural origin. Artificial objects are built to handle stress. They have structural reinforcement. They don't just disintegrate. The light curve. How much brighter the object gets as it approaches perihelion. Natural comets follow predictable light curves based on distance and sublimation. If Comet Atlas follows those curves, the natural explanation fits. If not, if it's brighter or dimmer than expected, and or shows unusual variations, that's interesting. It requires an explanation. Orbital deviation, any change in velocity that can't be explained by gravity and radiation pressure. Even small changes are significant. A few meters per second of delta V would indicate thrust, would prove a propulsion system is active, and would prove an artificial origin beyond a reasonable doubt. This is what we really want to measure. But it requires precise tracking before and after perihelion. To compare the orbits is difficult with the object hidden behind the sun during the critical window from October 30th to November 6th. The Europa Clipper and Hera spacecraft will pass through the expected tail region. These missions weren't designed to study Comet Atlas. They are heading to their own targets. Jupiter's moon Europa for Clipper, the Didymos asteroid system for Hera, but their trajectories happen to take them through the region where Comet Atlas's ion tail should be, if it has one, Europa. Clipper has instruments that can detect charged particles, magnetic fields, and plasma. If Comet Atlas is outgassing and creating an ion tail, Clipper will fly through it and measure the environment. That tells us the composition, particle density, and magnetic field structure. All of this is useful for characterizing what the object is shedding. Hera doesn't have the suite of instruments to collect as much data, but it does have a camera. If the tail is bright enough and positioned correctly, we could get an image, a visual confirmation of the tail's structure and extent. This is a passive observation. The spacecraft aren't maneuvering to study Comet Atlas. They just happen to be in useful positions. But we take what we can get. Any data is better than no data. November 4th. The observation window for the JUICE spacecraft. The Jupiter Icy Moons Explorer is currently between Earth and the Sun, on its way to Jupiter. Its trajectory brings it within 64 million kilometers of Comet Atlas on November 4th. That's much closer than most Earth-based observations. Close enough for detailed imaging and spectroscopy. JUICE has cameras, multiple optical and infrared cameras. It has spectrometers to analyze composition. It has particle detectors, and it can measure the cometary environment. This is one of our best opportunities to get high-quality, close-up data on Comet Atlas post-perihelion. What state is the object in? Is it still intact? Broken into fragments? Brighter? Dimmer? Has it changed shape? Are there any new features? Any accompanying objects that weren't there before? JUICE could answer these questions. And if its instruments perform as designed, and if mission controllers can fit the Comet Atlas observation into their schedule. They have primary mission requirements to explore the Jovian system. Comet Atlas is a target of opportunity, a secondary priority, but potentially valuable. Data from JUICE will not be transmitted immediately. The spacecraft is far from Earth, on the far side of the Sun, and communication bandwidth is limited. Priority is given to the spacecraft's health and navigation data. Science data is downloaded as bandwidth allows. The ESA estimates we will not see JUICE's observations of Bialis until February 2026. A 3-month delay is disappointing, but that is the reality of deep space communication. From November to December, Bialis emerges from behind the Sun and becomes visible to Earth-based telescopes once again. This is when observers, both amateur and professional, around the world will begin tracking it again, every clear night, with every available telescope, building up observations to see how the object has changed at perihelion. We are looking for the development of a tail. If it is a comet, we should see prominent dust and ion tails by this time. The solar wind and radiation pressure would have had time to build up significant tail structures. Those tails should be clearly visible, even in modest instruments. If we do not see them, that is significant. It means the object is not outgassing, which is strange for something that has just passed perihelion. Or it is not a standard comet. We are looking for changes in brightness. Did perihelion make it brighten as expected? Is it following cometary brightness models? Or is it doing something else? We are looking for morphology, its shape and structure. Has it maintained its elongated shape? Has it changed? Are there new features? Any changes in the structure of a forward-facing jet or an anti-tail? And, importantly, we are looking for companions. If Bialis deployed mini-probes at perihelion, they would separate from the main object. Over time, tidal forces from the Sun would gradually spread their orbits. By late November, if probes were released even with modest velocity kicks, they would be far enough from Bialis to appear as separate objects in high-resolution images, multiple points of light instead of one. That would be definitive. That would prove the deployment. That would confirm the mothership hypothesis. On October 19th, it makes its closest approach to Earth. Bialis passes within 269 million kilometers of our planet, a about 1.8 astronomical units, still far away and not dangerous, but close enough for excellent Earth-based observation. Every major observatory will be watching. Radio telescopes, listening for signals. Optical telescopes, imaging the structure. Infrared telescopes measuring the temperature distribution. And spectrographs analyzing the composition. This is our best chance to characterize the object in detail from Earth. If Bialis is transmitting a signal, we would detect it then. If it is artificial and wants to communicate, the closest approach to Earth is the logical time. Minimum transmission power required. Maximum signal strength for us to receive. If we are going to receive a message, October 19th is when we would expect it. SETI instruments will be listening, specifically looking for narrowband signals, modulated carriers, anything artificial against the background noise. They have done this for many decades, pointing at distant stars. Now, they have a promising target in our own solar system that is potentially technological. If SETI ever finds something, this could be it. On March 16, 2026, Atlas will pass within 54 million kilometers of Jupiter, close enough for the Juno spacecraft to observe. Juno is orbiting Jupiter right now. Its instruments designed to study the giant planet, its magnetosphere, atmosphere, and internal structure. They can be pointed elsewhere, and at 54 million kilometers, Atlas will be observable. Juno can perform UV spectroscopy, infrared imaging, and particle and field measurements. If Atlas is interacting with Jupiter's magnetosphere, Juno will detect it. If the object is emitting radiation or particles, Juno will measure them. If there are new structural features or companions in March, Juno will photograph them. This is potentially our last good look at Atlas. After its Jupiter flyby, it is heading back out into interstellar space, away from the Sun, away from Earth. It will eventually fade from view, too faint, too distant, lost against the cosmic background. We have not figured out what it is by March 2026. We may never know. So, we have a sequence, a timeline of specific dates when specific observations happen and specific questions are answered. This is not vague speculation. This is planned science. Observations have been scheduled. Known possibilities. Identified targets. We have done the preparatory work. Now we execute. Now we collect the data. Now we find out. Between each observation window, we analyze. We compare. We refine the models. We publish the papers. The community debates conflicting interpretations. A consensus gradually builds, or it does not, depending on what the data shows. This is science in real time. Hypothesis testing at the speed of orbital mechanics. It is slower than we would like, but faster than historical astronomy has ever managed. Think about what we are really attempting here. We are trying to determine whether an object from another star system is natural or artificial. We are trying to answer one of the most profound questions that humanity can ask. Are we alone, using telescopes and spacecraft, and mathematical models, using the scientific method, using rigor and skepticism and careful measurement? This is what we are good at as a species. This is our strength pattern recognition, tool use, systematic investigation. If there is an answer to be found, we will find it. But there is also the possibility that we will not. The possibility that Atlas remains ambiguous, neither clearly natural nor clearly artificial, existing in that uncomfortable space where we cannot decide, where different observers reach different conclusions based on the same data, where the mystery endures because reality does not offer a clear answer. That would be the worst outcome, in some ways, worse than a confirmed comet, worse than a confirmed spacecraft, because it would leave us in perpetual uncertainty, always wondering, always debating, never knowing for sure. The question unresolved. The mystery unsolved forever. We are tracking an object in space, watching it move, measuring its properties, trying to understand what it is and why it is here. In 8 more days, it will reach perihelion and potentially do something that reveals its nature. In 3 more months, we will get our best close-up views. In 5 more months, we have one last chance to observe before it leaves. That is our window. That is our chance. Then, Atlas disappears, and we are left with whatever data we manage to collect, and any conclusions we can draw from it. The countdown continues. October 29th is approaching. Somewhere behind the sun, hidden from our view, Atlas is experiencing conditions it has never before faced. In billions of years, heat, light, gravity, whatever it is made of, whatever it was designed or evolved to do, this is the moment. This is the test, and we are about to see the results. This is the test, and we are about to see the results.